Please take your seats. Please, ladies and gentlemen, take your seats. So, good morning again. Welcome to this France, Germany, São Paulo Climate Change and Biodiversity Scientific Cooperation Day. This is an initiative of the General Consulate of France in São Paulo, the General Consulate of the Federal Republic of Germany in São Paulo, and the São Paulo Research Foundation, FAPESP. To open this session, I'd like to invite the president of FAPESP, Professor Marco Antônio Zago. Our host today, Professor Liedi Bernucci, CEO of the Institute for Technological Research. Deputy Consul General of France in São Paulo, Mr. Christophe Alamelama. The Consul General of Federal Republic of Germany in São Paulo, Ms. Martina Hackelberg. And the Scientific Director of FAPESP, Professor Luiz Eugênio Mello. And to open this session, we'll give the floor to Professor Marco Antônio Zago, President of FAPESP.
Okay, good morning. Professor Liedi Bernucci, President of IPT, our host today. Ms. Martina Hackelberg, Consul General of the Republic of Germany here in São Paulo. Mr. Christophe Alamelama. I'm sure in the next weeks I will be able to pronounce your name correctly, fluently. But thank you for coming, Deputy Consul General of France, and Professor Luiz Mello, Scientific Director of FAPESP, my friends, invited speakers. This is a very special event because two of our most expressive and long-term collaborators in science and technology, and also friends of the research and higher education institutions in São Paulo, France and Germany, jointly invite us to a high-level seminar to commemorate the 60th anniversary of FAPESP. In addition, they chose as focal subjects for this seminar two of the most important global challenges of the moment: biodiversity and climate changes. I must thank both the German and French consulates and the researchers who have come to this meeting from abroad and also from here, from the state of São Paulo, to participate in this initiative. This is a very appropriate way to remember the 6 decades of FAPESP in Brazil's scientific scenario. Our programs of sustainability, including Biota for biodiversity, BUN for renewable energy, and research in climate changes, have existed for almost half of the life of the agency. In addition, there are hundreds of collaborations between researchers and institutions in the state of São Paulo and in both countries, France and Germany. Obviously, the collaborations between our countries and the region extend far beyond these areas of knowledge to include humanities and social sciences, medicine, life sciences, mathematics, law, economy, physics, chemistry, arts, and so on. But when society recovers from the most significant global disaster of this century, the pandemic of COVID, I think is the right moment to talk seriously and forge strong collaborations to avoid and to confront new challenges and global threats, such as those that will result from global climate changes and loss of biodiversity. So we need to prepare for that. Thus, thanking again all those responsible for the organization of this meeting, from the French consulate, the German consulate, and from FAPESP, and from IPT that receives us today. I wish you all a very productive day of work. Thank you.
Thank you, Professor Zago. We now give the floor to Professor Liedi Bernucci, CEO of IPT.
Good morning. We would like to welcome and thank you all participants. Thank you, Professor Zago, President of FAPESP, Professor Mello, Scientific Director of FAPESP, Martina Hackelberg, General Consul of the Federal Republic of Germany in São Paulo, Christophe Alamelama, Deputy Consul of France in São Paulo, for promoting this important event. Welcome the invited speakers who will present relevant results on climate change and biodiversity. Welcome all participants of this event. It's a great pleasure for us to host this important event at IPT. IPT is Institute of Technological Research. IPT is linked to environmental sustainability in several research areas, such as bioeconomy, circular economy, smart cities, renewable and sustainable energies, among others. Brazil is committed to important initiatives such as Race to Zero, Race to Resilience, reducing methane emissions by 30% by 2030, and we have started discussing the market of carbon credit. A study carried out by the McKinsey showed that Brazil could participate with 15% of the global market for carbon credits by the end of this decade. This market could generate around $2 billion by 2030. It's a big problem, but this is also an opportunity that Brazilians can participate. Complex issues can be addressed through collaboration between institutions, competent institutions. Alone, little can be done. I wish you a great and fruitful event. Thank you very much for coming. Have a nice one.
Thank you, Professor Liedi. We will now give the floor to the Deputy Consul General of France in São Paulo, Christophe Alamelama.
Viu como que ele falou certinho?
Mr. Marco Antonio Zago, President of FAPESP, Mrs. Liedi, Légi, Bariani, Bernucci, CEO of Institute for Technological Research, Mr. Luiz Eugênio Mello, Scientific Director of FAPESP, Mrs. Martina Hackelberg, Consul General of the Federal Republic of Germany in São Paulo. Dear researchers, dear friends, bon dia, guten Morgen, bonjour. I'm very pleased to open this event with you this morning. On the occasion of the return of the schooner Goélette Tara from South America, that was among other tasks doing research on microplastics in the oceans, Mr. Antoine Petit, Chairman and CEO of the French CNRS, highlighted the fact that the crisis we are facing clearly show us that we need science more than ever. Last summer, there has been a succession of heat waves in France, in Germany, and throughout Europe. A few days ago, mid-October, temperatures reached 30 degrees in southwestern France. Well, just heading to the university this morning, I was reading an article in the newspaper Le Monde saying that France would experience a 3.8 degrees increase by year 2100. That's incredible and amazing. Huge fires have ravaged forests in France and Portugal. A third of Pakistan's territory was flooded a few weeks ago. And lately we have got a clear view of what is in store for us in the coming years and decades. Threats to biodiversity are increasing. According to an article published in January 2022 by a researcher from the University of Hawaii, Robert Cowie, and two French colleagues, Philippe Bouchet from the Institut Systématique Évolution Biodiversité and Benoît Fontaine from the Muséum National d'Histoire Naturelle, published an article. According to them, 7.5 to 13% of animal and plant species vanished worldwide since the year 1500. Until then, it was only 0.04% that were missing. Applied to all living beings, this represents 150,000 to 260,000 extinct species. This mass extinction is taking place while we are far from knowing all the living beings that inhabit the Earth. For example, in the Amazon and the Andes, hundreds of tree species are still unknown to scientists. Since Aristotle, Carl von Linnaeus, and Buffon, scientists have been cataloging and classifying flora and fauna. But today, science is caught up in a race against time. We have to discover before it is too late. Moreover, before it is too late, science must be able to tell us to what extent our human activities harm the environment, to what extent the use of oil, gas, coal artificially increases the concentration of greenhouse gases in the atmosphere and as a result increase global warming. How does the climate change affect the oceans? How bad deforestation affects rainfall? We know that in order to answer these questions, scientists need good conditions to conduct their research. We also know that international cooperation is a key. It is all about sharing budgets, sharing tools, material, and knowledge. We are eager to enhance Franco-Brazilian cooperation on biodiversity and climate change. You may know it already. The longest border of France is not with Italy, Spain, or Germany. It is with Brazil. We share concerns. This is the reason why we are building bridges between French Guiana research and Brazilian research. And so the University of French Guiana and USP will soon sign an agreement that will encourage collaboration on biodiversity. Our scientific cooperation with Germany has never wavered since the post-war period. On the subjects of climate change and biodiversity, Our German friends are developing excellent research based on remarkable tools such as the ATO Tower. To respond to the climate crisis, governments must consider science as the basis for their climate policy. Defining public policies to reduce global warming and preserve biodiversity should be based on scientific facts. We have to acknowledge the research of members of the Intergovernmental Panel on Climate Change and the Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Services that includes Germans, Brazilians, and French. Ladies and gentlemen, 11 days ago, Bruno Latour, philosopher, anthropologist, and sociologist, died. We remember his legacy. He was convinced that public policies should open avenues of innovation made to maintain the reproduction of living conditions on Earth. I would like to greet here our German partners. The Franco-German couple has always enjoyed taking up challenges. We are facing a major challenge, and we know that we must unite in science so that we won't leave an uninhabitable planet for future generations. Finally, I would like to salute and congratulate FAPESP for its more than ever invaluable role in the Brazilian science and more widely in the Brazilian society. Marco Antonio Zago, Luiz Eugênio Mello, you provide scientists with the means to face the present time. This is essential both to prevent ignorance and the lunatic from becoming virtuous and to provide tools for the survival of our species and other living beings. I wish you all an excellent day and hope that trilateral collaboration will emerge from today's exchanges. Thanks a lot.
Thank you, Mr. Christophe. We now give the floor to Ms. Martina Hackelberg, Consul General of Federal Republic of Germany in São Paulo.
Dear Marco Antonio Zago, dear Luiz Eugênio Mello, dear Christophe Alamelama, dear speakers and panelists, dear guests. As my French colleague has just said, we need science more than ever. Science is not just an opinion. It is about information, the quest for progress and knowledge. You would think that this goes without saying, but sadly, it appears it needs to be emphasized again and again against the spread of fake news, attempts to discredit scientific research, and to limit academic freedom just because it is telling us uncomfortable news. In the same sense, climate change is not opinion. It can be noticed around the globe. Rising sea levels eat away coasts, islands, and cities. Fires diminish forests and crops. Extreme weather events destroy people's livelihoods. In Germany, in France, and here in Brazil, from one of the severest droughts in decades in the Pantanal to floodings and landslides in Rio. The IPCC reports reveal that a global warming above 1.5 degrees not only endangers ecosystems, but also political, economic, and societal conditions globally. Most affected are the poorest and most vulnerable groups and people. Climate change can also be a catalyst for tensions and conflicts. It is an existential threat to humanity. Yet science also tells us that a zero-carbon society is possible, a society of new green jobs and growth that can limit warming to 1.5 degrees. The European Union has already shown that it is feasible to decouple growth from CO2 emissions. Since 1990, our GDP has grown by over 60%, while net greenhouse gas emissions have fallen by a quarter. Last year, we released our legislative package to implement the so-called European Green Deal, and deliver a 55% net reduction in greenhouse gas emissions by 2030, on the path to climate neutrality by 2050. Obviously, the European Union cannot manage alone, as we only emit 8% of global CO2. We have to join forces on the path to climate neutrality. All eyes are now on the coming COP27 in Sharm el-Sheikh. Keeping global warming below 1.5 degrees is the major target. With the current NDCs, the national determined contributions, we stand at 2.4 to 2.7 degrees. That's the gap we need to close. We all need to act. For COP27, our goal must be an ambitious package that will encourage emission reductions and accelerate the energy transition. We must also provide more support for adaptation and to the most vulnerable countries to compensate for their losses and damages. Negotiations in Sharm el-Sheikh are, however, overshadowed by the Russian aggression against Ukraine and the global food and energy crisis provoked by it. As you know, the war forced us as Germany to make some bitter decisions to substitute Russian energy imports and ensure energy supply. But in no way our target has changed. Germany remains 100% committed to its climate goals and will continue to be a frontrunner. Indeed, the war has only underlined how important it is to become independent from fossil fuels. We are already drastically reducing our gas consumption, aiming at a reduction of 20% in the coming month. And we are accelerating our energy transition even more. Terminals are designed to be ready for green hydrogen, and we have put forward laws that will triple the speed by which we expand renewable energies. It also means that it is even more crucial for us to have strong partners to tackle the global challenges concerning climate change and also biodiversity. Brazil is particularly important to us and has a critical role in the fight against climate change. In many areas, we are already cooperating very well together, and there are many fields more for the future, such as green hydrogen. We hope to see many more cooperations, such as the partnership between the chemical company Unigel, which has announced recently to install the first industrial-scale green hydrogen plant in Bahia, employing electrolyzers from the German company ThyssenKrupp Nucera. It's one example how advantageous locations for production of green hydrogen in Brazil and German technology go hand in hand. Another very visible example for successful cooperation between Brazil and Germany is the ATO, the Amazon Tall Tower Observatory, a over 325-meter tall tower in the middle of the Amazon forest, where researchers from both countries collect data about the atmosphere and the biosphere. And here at USP, we have the Climapolis Laboratory, a long-standing joint project aiming to contribute to the development of environmentally resilient cities in Brazil. This is just to name a few of the many projects where we already join forces. I am sure that today's discussions will underpin this cooperation and inspire new insights and ideas. On this note, I would like to thank our colleagues from FAPESP and from the French Consulate, both very important partners to us, for the joint cooperation of this event. It is always a great pleasure working with you. And a great thanks also to all the speakers and panelists for being here with us today. I wish you fruitful discussions. Thank you very much. Merci beaucoup. Muito obrigado.
Thank you, Ms. Martina. We now give the floor to Professor Luiz Eugênio Mello, Scientific Director of FAPESP.
Bom dia a todos presentes. Good morning, bonjour, guten Morgen to all of the presenters on the opening session, Professor Marco Antonio Zago, Professor Liedi Bernucci, Monsieur Christophe Alamelama, and Mrs. Martina Hackelberg. So it's a great pleasure being here today on this opening event on a joint initiative between the German, the French consulates, and FAPESP. As it was already mentioned, FAPESP is celebrating its current 60th birthday, and definitely when FAPESP was being created, we wouldn't be having such a meeting because there was no concern, or the concern about climate change was not widespread to the citizens at large, or even to scientists. I think it was in the initial days of the realization that global climate change is a big problem. All of the presenters before me mentioned collaboration or cooperation in a number of ways. That's definitely what's needed for this current crisis, and it is what humankind has always devised as a means to solve great challenges. So it's impossible for any single country or for any single organization to address the problems that we currently face. And we must address those on a collaborative mode. And so having this event, which stresses a collaborative nature, it's of fundamental importance. Another perspective, which is often unnoticed, is with regard to the link between biodiversity and climate change. We often think that climate change leads to loss of biodiversity, and that's true. However, loss of biodiversity contributes to climate change. So there is a biounivocal relation there. In addition to that, as we work on preserving biodiversity, we definitely impact climate change. So we must look at this program from the perspective that it brings, which is not often taken into consideration. And those would be my opening remarks, and then I have the great pleasure to introduce our guest distinguished speaker, Professor Thelma Krug. Thelma Krug is a former senior researcher at the Earth Observation Coordination at the National Institute of Space Research in Brazil under the Ministry of Science, Technology, and Innovation. She was elected vice chair of the Intergovernmental Panel on Climate Change, the IPCC, for the 6th cycle of the panel between October 2015 and 2023, after having been co-chair of the IPCC Task Force on National Greenhouse Gas Inventories from 2002 until 2015. There are a number of other appointments which she had in the past or still currently has. And since 2020, the chairs of the Terrestrial Observation Panel for Climate Change topic of the Global Climate Observation System, GCOS, under the World Meteorological Organization's WMO, are also part of her functions. So with further ado, I would like to invite all of the components of the opening table to join the audience and to invite Professor Thelma Krug for her presentation.
Master Ed, she's a member of the board of a...
Important thing.
Here, free from the podium. I have been sitting too much to the virtual talks at home, so today I want to be free. Okay, this is good. Okay, good morning, everybody. Guten Morgen. And, well, first I would like to thank the organizers of this meeting, so General Consulate of France in Sao Paulo, General Consulate of Germany in Sao Paulo, and also FAPESP. This is really great initiative to be here. And also I would like to thank IPT through the CEO, to host us here, and also for the nice coffee that we had outside with the cheese bread. This is great. I mean, it's a good start. So, it was such a nice start today with everybody mentioning science. Many mention also IPCC. And I think there is a great linkage. And I always fear when I am coming free, because sometimes I have a big presentation and I skip them all and then talk freely. But I'm going to behave myself today as much as possible. So anyway, hearing the talks, it stimulates also my mind to see. I wanted to answer so many of the questions that have been posed. And I also wanted to say how important science is. And in this field, then, I thought that I would say, in my talk, climate change and biodiversity, because it's the Cooperation Day on Climate Change and Biodiversity, and the latest scientific findings of the IPCC. Why did I think it was good also to have a starting, saying what is IPCC, and the importance of this meeting and the cooperation, international cooperation, because how is science done under the IPCC? This is what I wanted to start with. And with that, let me see if I can handle this. These technologies are complicated. Cadê Marcelo? So now let me see if I can move. Yes, I can. Okay, that's great. I always fear, these technologies. So what is the Intergovernmental Panel on Climate Change? Everybody says, well, it's a governmental panel. 195 member governments that have been working together for 33 years, basically. I have been 20 in so many years with the IPCC, as Luiz has already mentioned. And so quite involved on how all these huge reports from the IPCC are produced. IPCC does, if you ask me, how many people has IPCC? It produces assessment reports every 5.5, 6 years, this time because of the pandemic, 7 years, producing about 10,000 pages altogether of science. How is this done? How many people does IPCC has? Essentially 12 people, right? Everybody of these 12 is paid. All the rest, which you are going to see, that produces these 10,000 pages or more, are all voluntary work. Chairs, vice chairs, co-chairs, everybody's voluntary for all this time, right? So it's nice to be there on giving your time and a lot of your life as well to science. So IPCC has the mandate of assessing the literature, assessing all that is constructed all worldwide in all aspects of climate change. So we are talking about, as you are going to see, the structure of the IPCC. You are going to see that it has the physical basis of climate change, also another group that works with impacts, adaptation and vulnerability, and another one that is the solution space of climate change, which is the mitigation group that tries to bring some light on what can be done to cope with the threat of climate change. So we cannot be prescriptive, so nobody's going to see anything that says, well, countries should be doing this or should be doing that. What IPCC says, and I'm going to show some of the slides, is if you choose to go this track, this is what is going to happen. But you can choose yourself. So this is why there is some, I wouldn't say uncomfortness, but there is frustration of the scientists that devote so much time into bringing science. Science is so clear. And then where's the action? So when we go to COP, as has been mentioned here, COP27, we all want to have ambition, but is ambition coming to the table? Not to the extent that it should. But this is global, I mean, so everybody has to do these efforts together. So we are not prescriptive, we need to be relevant, so this is what we aim for. As I already mentioned, well, I didn't want to bring this one here. Yeah, okay, so it's coming, I hate this. So as I said, this is the structure. We have these 3 working groups. The structure is maintained for many years. Some time ago, IPCC or the panel, the 195 governments that have to agree by consensus, thought that we should bring adaptation and mitigation together. But the structure remains the same. Last month, they discussed that this is going to be the structure. And you see there the task force that I have co-chaired for many years, Task Force on National Greenhouse Gas Inventories, which is just the part of the IPCC structure that develop methodologies for all the countries to report their greenhouse gas inventories in a relatively harmonized way so that countries have more or less the same way of reporting and with some freedom, obviously. But anyway, this is my preferred bit because everybody has to use those manuals. But anyway, so plenary are the government's bureau is a council that helps the plenary in many aspects, scientific aspects, but the main part are the authors and other parts that I'm not going to go through. This cycle that started in 2015 and ends next year has been very ambitious. We had these 3 assessment reports that were finished this year. The first one on physical basis, science basis, was finished last year in August. Impacts and mitigation have been delivered this year in March and April. So altogether about 10,000 pages. I need some water if somebody can. Yeah, please, thank you. And besides this, we had also 3 special reports which are done in a smaller time frame. We had one that was an invitation from the Climate Change Convention that addressed global warming of 1.5 degrees Celsius, that worked with the impacts of 1.5, and also what would be, so not only the impacts of 1.5 degrees Celsius, but also how could we get to limit warming to that level by the end of the century? There are numerous ways that you can get there. There is not only one emissions pathway, but every single one has an implication. So the IPCC report on 1.5 points to those. We also had one on climate change on land that talks about degradation, desertification, food security, and terrestrial fluxes and so on. And another one on ocean cryosphere in a changing climate. So those were smaller, 700 pages more or less each one of them, but they are produced in 2.5 years, while these assessment reports are produced in 5 years. Paulo is here. Paulo knows more or less how long does it take, right, Paul? During the pandemic, all this work was done virtually. And enormous effort because it was an impediment for people to be, the researchers to be in touch with each one. So that was really, a bad momentum for all of us. What I wanted to show here is how do we produce these? And I always say that IPCC is one of the best examples of this policy interface between science and decision-making. And why do I say that? Well, it's an intergovernmental panel, right? It's the main user of the IPCC reports are the governments. So they are the ones that normally like to scope, like to say, what do we want to see in these reports? And why is that? Because scientists sometimes have, their bias. They like to put, the things that they are doing, but not necessarily those respond to the to the expectations of the governments that have to devise the policies and so on, right? So governments usually say, I want to see a chapter on this, a chapter on that, gives bullet points, and then ask the researchers to elaborate on what they can deliver, And then the researchers come or the scientists come and say, well, we think that with the available science, we can deliver what you're expecting. We are adding this and that and that. So governments in a panel meeting, everybody together, approve the outline. Everything is by consensus, all the 195 governments. Then after that, there is a nomination of authors, usually done through the ministers of environment or foreign affairs of each country. Authors are selected. This is interesting. Selection of authors comes from the nominations, but there are some elements that we want to ensure in the selection of authors. The first one of them is that you want to ensure a geographical balance so that you ensure that you are not going to have a biased, let's say, report that would have more or less, you know, the visions or the literature or bias towards a part of the world or another. Also, we try the best we can to have women, a gender balance. This is more difficult. This is more difficult. But during this assessment, which is the 6th assessment report of the IPCC, we had 32% of women, which was the highest we had, 34 in the previous one that ended in 2014. And we are increasingly trying to see what is it that barriers governments to nominate women. Don't they know where the women are? Or the women do not want to engage because it's a too long period of a commitment. And then they have to come to the meetings in person and so on. So 6 years, 5 years, it's too long a period. So maternity has been seen as one of the impediments. But now we are seeing, you know, husbands coming together with the women waiting on the outside in the corridors while the women are inside, you know, drafting the reports. So that's good news. It's improving. But then it starts to be interesting because then there is a first draft that is very crude, let's say, and that goes to experts around the world that send several comments, some 1,000 comments. And these have to be addressed by the authors. A second draft is done, and then it goes to the governments to review. This is why I think that there is this good interface, because governments can see these reports. They can comment, and they can indicate any prescriptive language, or they can also say, well, there are some pieces of literature that have not been included, so I'm suggesting this and that. And it improves a lot, so you have a second draft. Second draft goes back to government so that they have another chance to look at these reports. Offers an opportunity for the governments also to know and understand the science behind climate change, right? And then, because the reports are so big, there is what we call summary for policymakers. And this summary is about 35, 40 pages and brings the main messages from the big report. Well, this is... eu já vou passar para frente. Bem rápido. So, okay, sorry. It was not a bit long. So I get really excited about this. But anyway, the summary is approved line by line, by consensus, by all governments. Governments are there. They know the scientific message because they are there. Agreeing takes a week to agree on the language and everything, so they know the science. Everybody knows the science, so let's go. Let's go and see where we go. So, right, where are we? It has already been said. So, human activities led us to have now a 1.1 degrees Celsius above pre-industrial times. We normally say pre-industrial times, we consider the period between 1850 to 1900 because that's when we have data available. And so on land, we have a largest warming of 1.5 and over the ocean 0.88. And there is one thing interesting because when the authors are assessing all the literature that is available, and these are thousands from all over the world, it's not a cut and glue. What they have to do is to do an assessment, and then based on the evidence and based on the agreement in the literature, they have what we call this calibration language. And I am giving here some examples of the calibration language. I picked just a couple of examples. Like human influence, very likely. That's a calibration, very likely. That has a probability between 90 and 100%. And main driver of global retreat, of glaciers, virtually certain. Wow, when the governments hear that, they say, well, that's pretty good. Huh? But they want to know how many pieces of literature did you assess. They asked that during the panel meeting that is going to go line by line. Well, how many pieces of literature? How did you get to that result? That is bringing me almost confidence that this is 99, 100% is basically Anyway, extremely likely. But you have also something like those extremely unlikely, between 0 and 5%. So you have a range of a language that gives government a very good idea of how mature that is based on the evidence and how much the literature agrees. Well, that became a fact. It was not a fact that human now has an unequivocal influence on the climate system, has warmed the atmosphere, the ocean, the land. It became a fact, and I think that something interesting is the order. Yeah, I wanted to show this one. I love this. On the right, let's see on the right. If I try to see the change in the global surface temperature from 1850 until 2020, what you see, these changes, annual average, on the black line, And if I try to fit that line with simulations that include only natural drivers, like, for instance, variability of the sun, or if I want to include volcano eruptions, which are natural, right? And that's the blue line there. Particularly from 1970, we cannot fit the observations. You only fit if you go through the brown line that you can see very much closely adjusting, the observations. So that's natural plus human. And this is one of the observations that led us to understand that humans have an unequivocal influence on the climate system. So they are causing also the extreme events, and we know about this, droughts and heavy rain, very hot days, and these are becoming more intense and more severe. Has caused many of the dangerous and widespread disruption in nature. And this is one of the slides that I like to show. This comes from Working Group 1. And this is the world depicted there in subregions. I think I have something that, yeah. So basically we are here in Brazil in these 4 subregions here. Amazon is basically here. Central Brazil is here. Semi-arid here. South Brazil is here. And what it shows in those colors is the relation with an increase in the number of hot streams. So you see that in terms of hot streams, almost the whole world is experiencing an increase. Now, what the IPCC tries to do is also to attribute those increases in hot stream to human influence or not. And this is why it is not very clear, but you can see that it includes the confidence level on saying, yes, there has been an increase here in the southeast Brazil, and you have 3 dots there, which implies that you have a high confidence that that increase has a human digital on it. In other places, you may have less. Some places you don't have enough information, or the evidence is limited. When we come to precipitation, heavy precipitation, you see that there are a huge number of blocks that has limited evidence. And then the only place where you have, say, and it's not with a very good confidence, in the southeast Brazil, where you do have an increase in heavy precipitation. But there is still a weak, human digital into that. But you see that, this is, you have much more confidence in the temperature increase than you have in association to human digital than you have for precipitation. Now, this is a new report of the IPCC, especially the one on Working Group 2, that talks about impacts, adaptation, and vulnerability, talks now about what is being called the compound events that cascade as well. So what I'm talking about that is you can have more than one extreme event. So you may have a drought that's prolonged, and then together with that you have a good number of hot days. So you are compounding the drought plus the hot days, and you may have also a lot of wind that would then compound to have, enormous amount of fires. But, these compound events promote a heat stress among the workers, so that leads to reduced crop yield, reduced productivity, so it cascades into other social elements that then reduce the household incomes, have global impacts on food prices, and so on. So it's interesting that in the report, it says that Amazonia is going to be one of the regions in the 21st century that is going to be most affected by what is being called weather fire. And weather fire is a compound event between drought and hot days that will lead to these, enormous amounts of fires. And this is why I chose to talk a little bit more about adaptation of climate change. We talk about a lot on mitigation. And today we heard about this, we need to do more, we need to have ambitions, but we need to adapt as well, because some of these, need to be done, and it's already late. We have an adaptation gap, which is incredible. So in this cycle also, there was a strive to acknowledge the interdependence between climate, ecosystems, biodiversity, and human societies. And through that understanding of these dependencies, to put a lot of more efforts into integrating social sciences, the natural and ecological sciences, and also the economic sciences, which has been broadened if we consider what was done in the past. But this also comes because you have more literature available, more of this integration between, including the social aspects of the changes that is seen. So you have the natural sciences that are identified, but you need to bring the social element beyond also the economic value. And yesterday, Professor Zago, we were discussing strictly on this issue, on integrating more of the social science into the research. And then, well, I don't like to do that, but I thought if these are going to be available, it would be good to have the reflection of the whole text for people to understand. I like the second one that says that risks compound, and we talked about these compound events. From deforestation, wildfires, urbanization, and climate change in Amazonia impacts biodiversity, livelihoods, and also all the way people see their land. We have lots of indigenous people, local communities, and all these risks, can disrupt, let's say, their cultural aspects of their livelihoods. Also, a lot of talking about Amazonia, going in some parts from sink to source. Basically, the last one says about this periodic droughts in parts of the Amazon since the 90s. Partly attributed to climate change, but I think the next slide is going to show a little bit broader aspects, but momentarily then turning the forests from being a carbon sink that take more of the CO2 than emitting. Okay. And obviously this also has been said as climate change increases, as the global warming increases, then the risks are, okay. I still have 30 slides. But I'm going to go fast. Luiz, when I talked to you yesterday, I said, well, let's leave some time behind so that we can have questions from the audience. You're giving me 5 minutes for that. Okay, so obviously all these risks are projected to be much more frequent and intense as global warming increases. And I'm going to go a little bit beyond this, because this is being left behind. But there is observed. It's different from us projecting. There are observations in many global observations, regional observations, but I would like to go to this last line on how species are responding to climate change. And the species can respond to climate change in many different ways. So if I go to this last line that says biodiversity hotspots, in Brazil we have some of these hotspots. All the world has some of these hotspots, but they have already been impacted. How these species are coping. Are they having time to adapt? Most of the time they don't. And now because of the more frequent and more intense events, they are going to have even less ability to adapt. So if we go to the biodiversity hotspots here, obviously this is global, but they already have a change in the terrestrial, terrestrial freshwater in the ocean. So they already have with high confidence here, there, the confidence. So they have already had a change in their structure. They also can shift from places. They leave the places where they are, trying to look for places that are more representative of their endemic, places. And then you see that for the hotspots, you have got already all the shifts, including in phenology, their life cycles. So this is the way they are adapting. They are moving. Some types of fishes that have already left the place where they used to be, and going to places that represent more, the temperature they were used to. The ocean has already, warmed from 0 to 700 meters. They have to go somewhere else. So this puts at stake some of the subsistence of some of the communities that live of that. Okay, very quickly, this is now projected. This is what IPCC has done. How does IPCC project the future? Well, it projected their scenarios, constructing some scenarios on how the future can develop. How population can grow, technology advances, maturity, deployment, global relations, cooperation. That has a huge impact on how the future can develop. So in particular, IPCC has put together 5 scenarios that goes the 2 top from high and very high emissions until the end of the century, 2100. 1 intermediate scenario and the 2 bottom that goes with very low and low emissions until the end of the century. If you look, the 2 ones on the bottom go below 0. And why is that? That is because all the models that have been assessed by the IPCC that limits global warming to 1.5 degrees Celsius, all of them at around 2050, 2055, they have to zero the net emissions of CO2, 0. We are talking about energy being zeroed. We are talking about agriculture, land use, deforestation. We're talking 0 everything. But especially in industry, this might be challenging. And this is why you need to have something to compensate those residual CO2 emissions that could not be zeroed. And then I think that land has a lot to do with those carbon dioxide removal options that include not only land, but oceans as well. Fertilization of the oceans, large-scale bioenergy with carbon capture and storage, large-scale afforestation and reforestation are part of these options that could lead us to compensate, and this is why we say we are going negative, to really bring us down. Not only compensating for the residual, but us trying to lower the CO2 concentrations in the atmosphere. Which way are we going now? It has already been mentioned that if we put together all the nationally determined contributions of countries, everybody has put their intent to do something, Brazil including. I think Brazil could do much more, could do much better. But anyway, this is something else that we can talk outside. But anyway, Brazil has an excellent opportunity. But anyway, if we are now in the trajectory of a mode of 3.2, if we put together everybody's contribution. So we are far, far, far away from being, in the direction of meeting the Paris Agreement goals of temperature well below 2 degrees Celsius and pursuing 1.5. And I was so happy to hear Germany saying, the German Consul saying that, COP is striving to maintain the 1.5 alive. It's becoming almost impossible to do that. But let's please continue to strive to that. So, very quickly now, Luiz, I'm going to go and I'm going to leave this behind. But we see here, let me go to this one. I think this one is better because it's a piece of that one. So we see some biodiversity loss at different warming levels. So we see here how much would be the loss on the world at 1.5 degrees Celsius compared to 3 degrees Celsius. So we see the risk of extinction coming into play in biodiversity hotspots that increases about tenfold from going to 1.5 to 3 degrees Celsius. So we would see these species extinctions and losses of entire ecosystems, mountaintops, tropical coral reefs that are already endangered. I'm going to show something that I think it's really important to show. Every small increase in warming will result in increased risks. I think this is the natural result. I would like to go to this, Luiz, and I beg your indulgence with me. You see the black lines are where we are going in terms of global temperature change, increase since, in this case, 1950 here. And what you see on the right are basically what IPCC calls, since its third assessment report, of reasons of concern. I'm going to just go into the first two because the remaining you can also go to the report and see. The first one of these reasons for concerns concerns the unique and threatened species, or ecosystems. So we are talking here about the coral reefs. We are talking here about the biodiversity hotspots. We are talking here about the Arctic Sea ice. So when you see the line that is crossing those diagrams there in gray, it's where we are, 1.1. So that's the temperature that you see there. So when you move from yellow to red, and then you go to purple, you see that the risks of the impacts are becoming higher. So if you look at what is happening at the current temperature with these unique systems, is that we are already transitioning from a moderate to red risk. And then if you go to the extreme events, which is the second reasons of concern, we are already leaving from the moderate impacts or risks into higher scale. So you see, when you go to those emission pathways, the highest you go, the worse we are going to be. At 2 degrees Celsius, basically the coral reefs are going to be extinct. At 1.5, we are going to have something like 90% of what is remaining now. So it is really a tragedy of the commons, Professor Zago. So this is what I mentioned when I say we show this. Now, the choices of the governments, right? So there is something here that shows that more, here on the top, we are talking about the events that are becoming more frequent, they are becoming more intense, and this is leading us to move from a situation where extremes could be survivable, but here you would be on the extinction lane. We had one examples or some examples already of species that have been extinct, gone from climate change. Luiz, I'm going to go very, very fast. I'm sorry. This shows basically the simulated annual temperature change at different warming levels. So what you see here, just to have a vision, this is the observation. You see some blanks here because you don't have data. But here are the observations of the annual mean temperature change in the world, and these are the simulated. This is the simulated. So you see a very good match between what is observed and what is being simulated. And this is at 1 degree Celsius. And here you go 1.5, 2 degrees, 4 degrees, and you see that this is becoming unlivable. Hot streams, as has been already mentioned. So basically, Liedi, you're looking at me. Luiz gave up to me some of the adaptation actions that could be taken. I'm going to mention just a couple. Protection in the terrestrial ecosystems. We could have basically, let's take this one, protect, restore, and create large areas of natural and semi-natural habitats. On the freshwater here as well, protect and restore the natural vegetation cover in catchments. You also have in the ocean ecosystems. So the IPCC provides a lot of examples of adaptation as well as mitigation. Just to talk about mitigation just in one sentence, IPCC says that we have mitigation options in place today to reduce by half, at least, the emissions in 2030 relative to 2019. Obviously, there are barriers. For developing countries, the main barriers are financial barriers, but they are not the only ones. You have institutional, socioeconomic, ecological, technological. So we still have barriers, but they are there. They could be implemented. And I'm going to finalize. There are limits to adaptation. Maybe past the time, you're not going to be able to do it anymore. Maladaptation, when you try to respond to something that's happening now, but doesn't have a long time livelihood, doesn't stand for what's to come. If it's to come more frequent in intense events, we have to react differently. So now coming to the end. Now coming to the end and to this event, IPCC mentions it very clearly. Cooperation, international cooperation, is really one of the main drivers of the implementation for both adaptation and mitigation actions. I would go a little bit beyond, saying that international cooperation is really the key for us to ensure that we can collaborate in science. We can cooperate in terms of the development of research. We have excellent programs that we had in the past. The large-scale atmosphere, biosphere experiment in Amazonia was one of the examples. How many years we have it now, Paulo? How many years we have? 1992, I think 40 years. It's still there. FAPESP has, supported many of the researchers, and many of this research goes into the IPCC reports. So essentially, you get all this information coming from the result of literature, from research that has to be supported, by funding agencies, has to be supported by international cooperation. And this is one of the reasons why I really appreciate the opportunity to have Germany, to have French here, and because I am absolutely sure that together we can do more than when we are singles. So let's put our hands together and, let's improve those language there. Thank you.
I would like to thank you very much for the excellent presentation and to mitigate our time and adjust. We'll ask everyone for us to have the questions in the coffee, as we have a coffee break now. And once again, thank you very much for excellent talk. Thank you. Muito obrigado.
Excuse me, you all. Excuse me, you all. I've been advised to, if you go outside the room, you leave your belongings with you. It was a phone advice from the organizer of the venue. Please. I'm sorry about that. That's it.
a new science section on this important workshop. So basically now we will get some examples, some discussions on collaborative research on climate change. As you saw from Thelma Krug presentation this morning, there is no climate change research without international collaboration. It's as simple as that, you know. So every research on this area knows this very well and is in general very well connected. So basically for our session, we have three distinguished speakers. The first one is Elbert Macau. Elbert Macau is a full professor at UNIFESP, in the Institute of Science and Technology of UNIFESP in São José dos Campos. He is an expert on dynamic complex system and also complex networks. He worked on the Brazilian satellite research program, as well as more recently in research using complex neural networks for studies in Amazonia. So follow after that, we have Professor Vincent Vantrepotte, that is from the Laboratoire of Oceanology and Géosciences, CNRS, from France, and he works with the techniques of remote sensing, especially on the ocean, but as well more recently also in Amazonia waters, that I think he will talk a little bit about that. And finally, we'll have another important research area with Pedro Brancaleon. He is professor at ESALC on silviculture, tropical silviculture. He developed innovative models for forest restoration and recuperation of degraded areas. So actually, three different topics that I think is very well represented in terms of international partnership. Each of the speakers will have 20 minutes, and then we'll have at least half an hour for discussions on these important themes. So I would like to invite Professor Elbert Macau for his talk. Please.
Hello, good morning. Thank you, FAPESP. Thank you, Paulo, for the invitation. It's always a pleasure to be here and to talk about our experience in this amazing project that we developed together with our friends from Germany. And also I'd like to acknowledge Márcio. Thank you so much. Márcio is a partner and he helps us all the time along this project. So, I'm going to talk about this project. Actually, how it works. Actually, the name of this project is Dynamical Phenomena in Complex Network. It was a long-term project, and it involves a joint collaboration between DFG and FAPESP. And I was the Brazilian coordinator, and my partner, Jürgen Kufs, was the coordinator from the German side. And first I'm going to tell to you about our experience, and later on I'm going to tell about some highlights, about some results that we got about that. And how to work? Okay. So first of all, this project, it lasts from 2011 to 2022, and it has two leading institutions. Humboldt University from Germany, National Institute for Space Research, the same as Thelma belongs. And at that time, actually, before UNIFESP, I worked for INPE for 32 years. Then I retired, and now I'm UNIFESP, very happy at this time. So Humboldt University it's one of the most famous universities in Germany. It has several Nobel Prizes. And INPE, that was our leading institute for climate, space, and astrophysics, and so on. And it also involves other partners. All this university, as you can see, is a very long list of partners from USP, Potsdam Institute for Climate Change, UNIFESP, University of Potsdam, CIMADEM, Federal University of ABC, and other institutes. And actually, it is very not easy, this project, because it involves two countries that are very far away from each other, as you can see. And even in Brazil, São Paulo is a very huge state. And if you take the states where the universities are located, we have almost 500 kilometers from Ribeirão Preto to Cachoeira Paulista. So to handle that, to make people to collaborate, to make people to interchange, it was very, very, very challenging. And I will tell you some things that we have done at that time. And it was in the time that we were not able to work remote, right? 2011, it was very difficult to have video conference, but it's not that easy to interact with each other. So, this project, the main issue is complex network. What's complex network? We have a large number of nodes, nodes that they have a non-trivial interconnection. It can be anything. And what we have, for example, here is people that are joined together, but in a regular way. This is a not complex network. However, if you have like that, World Wide Web, with the sites and the links, here is a complex network because it's very involved, the interconnection. So this is what happened, and it's a very powerful model to take how the people interact, how the nodes, whatever. It's actually a model for interaction. For example, if you have a Facebook, we can use that to model as a complex network, and you can capture social interactions and patterns that arrive and other things out of that. But it is actually a model. It does not matter what it's come from. We have the results, and out of the results, you can go back to where it comes from and get our conclusions about that. So, in this project, we are working in the focus with complex network that evolve in time. It means that the structure and the transmission, the dynamics, all the things change. And also the interaction between them are non-linear. It means that they are very, very, very complicated and change the time always. So, and it involves several themes, like, for example, neuroscience, climate, epidemic, and power grids, smart grid. It involves a lot of things, and all of them, we use this complex paradigm to make sense to get our results. And so we get together a very large team of Brazilian and German with all this expertise. For example, I am in engineering, and we have climatists, mathematicians, meteorologists, and other words. And those are the areas. So we have a theoretical area based on dynamics, nonlinear dynamics, complex network, and also stochastic dynamics and transport, and then where these areas are applied, like earth science and network and neural network. It means that earth science, we have the problems, we have what they wanted, and we develop tools based on the interaction and the fundamental theoretical point of view to solve the problems that get in all those areas. And it was a very interesting interaction because the people that they have the problem, they have their needs, and out of that, they push us to provide a solution from them. And also, it involves the training. We have to form PhD students. From the German point of view, this is a project with the focus is also to train students. We need to have several PhD that was training to work in this area. And also do research, okay? And it's a very interesting approach. So let us talk about the issue of this event. It's climate, where we apply a lot of this methodology that I'm talking to you about. As we know, as Thelma told to us, climate is a very complex system, involves a lot of interaction, involves a lot of issues, the human issues, the change in the earth, and a lot of things. And our goal is out of that in this globe, and also with all the things that can happen, can change, can evolve, we wanted to construct, to build a network. And this network is to make sense and to allow us to understand the phenomena, the climatological phenomena that take place in our world. And we did that with several approaches. So we start here in 2012. This was our first meeting, a presential meeting. As you see, we're able to see people, to see the other. And before that, me and my partner, we talk, we have a very conversation for over a year. We organize a workshop. FAPESP allow us to do that. We get people together, people who does not know each other, and they come up with the ideas and the projects. And finally, we submit, and after 2 years or a year and a half, we have approval from the FG and for FAPESP. It was a long process, and then we started this. And it ended in 2015. We submit another proposal who end up to be approved and allow us to continue our project. Please, Paulo, control my time, okay? So we have a lot of workshops, and students and people can discuss our interesting issues. And out of that, the idea came, and actually we are able to focus on problems that are beyond the initial goals or initial projects that we are planning to work. So it was a very amazing interaction. In the beginning, almost nobody knows each other, but as time goes by, we are able to get friends, to make things happen in a very amazing and fast and productive way. It was one of the most interesting experience that people had. So, let us talk about some figures, okay? So, out of these 2 projects, we have about the number of PhDs that we have. The Brazilian, it was 13, the first project, and 18 the second. From the German side, we have 15 in the first project, 16 in the second project. About the paper, these numbers are from the FAPESP database. We have 117 in the first one and 178 in the second project. So I think that we have a very robust numbers of papers and results. And at that point, I need to say that this paper, the results, it was very important because some of the results, some of the methodology that we've developed was implemented, allow, for example, people at INPE, at CPTEC to improve the model that they use to forecast climate. Some of the results was implemented and was tested, and they are working fine. And to end this project, we had this special issue from in this European Physics Special, I forgot the name, European Journal of Physics Special Topics, with 34 papers from all the group, and we highlight the contribution that we had all over the project. It was printed in 2021. It was very interesting, and that's synthesized. So now I'm going to talk about some results very quickly. I'm not going into details, just to show you. So from the people from neurological science who got this problem. So imagine that we have the brain, and we start to measure. We have some points that we measure that, and we have time series, and out of that we need to have the following question: who interact with whom? Who influentiate with whom? And I need to say that this is a directional influence that we need to find out. This is not easy to tell, to get this problem solved, because we have nonlinear interactions and also indirect interaction, and it's a very, very, very sophisticated problem and complex problem. But we are able to came out with a very interesting idea based in recurrence. Recurrence is a concept where we found that the trajectory with some general conditions, they recur, they come back to each other after some time. And based on that, we developed a tool that we can use it to find out this network based on entropy. And this was a very important result because it allows us to get the interaction in all the problems that we are involved. So let me tell it to you now some examples of the results, someone that I like most. For example, extreme events in Brazil. And as Thelma told us, we now have, you're here, sorry. We have now a lot of extreme events. For example, the rain in São Paulo is continuing to rain the same amount of raining that we had, but now is spotted. It rains all the things in a small geographic area. So it is an example of extreme events. And in this project, we are able to analyze some problems, and it works like that. The climatologist talk to us, and they tell his concepts about the phenomena. And they ask us, can you tell to us that it's really true? Can we develop a tool that allows us to forecast when this problem will happen? So you imagine, it's very complicated, and then we go to our methodology, we study, we try to find out, to develop tools, and then we come back, and it is a very involved interaction, very funny, and sometimes they say, oh, it's not like that, but we have some results. So let's talk about the drought in Amazon. This is Amazon sometimes, and from time to time, and we had 2005, 2010, this terrible drought. And let me tell you about the problem that we face here, the drought in São Paulo, Cantareira Reservoir, and actually the lack of precipitation in Northeast. So we work on this extreme event problems. And to do that, we are able to come up with very new tools to allow us to make sense of this problem. All of them are based on one that we call DPL, that out of index, we can take a scenario that allows us to forecast, to see, to analyze, to statistics on where the next event will happen when they started. For example, here is how many days it will happen until to get the threshold that we consider that is the limit for extreme event. So it means that all the phenomenon that out of this line is considered to be an extreme event. Extreme event, we can say that, for example, you have an index, and if it comes an event that over 80% of this, you have an extreme event. And out of that, we developed a lot of mathematics tools. Out of these, we analyze a complex network, and we're able to find out some very involved, interesting results. For example, for the drought in Amazon, we are able to find that those droughts was completely different from each other. And we're able to say that, for example, here is the Amazon, North Amazon, South Amazon, El Niño, North Atlantic, South Atlantic, who are able to influentiate it. And we are able to show that there are different droughts. For example, in 2005, El Niño has nothing to do with that. And actually, it was South Atlantic and North Atlantic. In 2010, El Niño influenced Amazon, and later on, North Atlantic and South Atlantic. And it's very important to tell, because when we, so what it means? It means that when the surface of the ocean, the temperature increases, it has a powerful influence over where it acts. For example, here we are talking about increasing the temperature of ocean about 1.5 centigrades above the average. And because of that, it has a strong effect that actually implies this drought. So when Thelma told to us about 1.5 increases in average temperature, you can feel how it means. It means completely change. It means change the pattern that we're able to see in our world. Okay? So so here we can sometimes, we used to blame El Niño, but it's not the case. Sometimes it's other Atlantic Ocean, north and south, and the increase of the temperature in the ocean that implies in this change. Why this thing? So it's a question that the climatology has a theory, but I'm not going details on that. But so about the São Paulo drought, that it was scared, that we thought that we were going to die without water, without energy, without air condition. And we used DPL, and we were able to find a very interesting scenario. What happened, it means it is related to the fly rivers, you know. The trees in Amazon, they develop by biodiversity a very interesting phenomena that they are able to send growth, to send dips in grains in the atmosphere, and the humidity that goes through the Amazon, it produces rain, and out of this rain we have the underground with humidity, and the vaporization of these trees, they send water vapor to the atmosphere, and then it goes in direction to the Andes, but it deviates that and come to the southeast, and produce rain here. So we just have rain here because of the Amazon. Otherwise, we are going to have the same climate that we have in Africa, which means savanna. So if you do deforestation, it means that we are going to end our rains here. And we are able to find out that this problem, what happened is actually excessive increase in the temperature. It means 2 in the Atlantic Ocean, and we are able to see that. And then what happens is that we have a feedback scenario where, because the temperature is higher, we are not have clouds, and because of not have clouds, we have sun, and the sun increasing more the temperature of the ocean, and this do this draw. It means that if you pay attention to this scenario, we are able to forecast next draw. I'm finishing. Then we are able to work on the problem of the precipitation shortage northeast. And you know, this is a very complicated problem because we do that based on precipitation index. However, you know, in the northeast, we do not have precipitation index because it's so small that makes very difficult to work on that. And starting in 2012, we have a very strong draw, the worst since they started to record it. And we developed a new approach. So we try to find out who is responsible for that, and we develop a new approach based on synchronization, and I'm not going into detail of that, but what we find out is the following scenario, that almost all the situation that imply this precipitation lack is because of the following, the influence of the North Atlantic. So North Atlantic influenced northeast of Brazil. But El Niño influenced North Atlantic. So El Niño indirectly is related to the draw in the northeast, but it can have this draw without El Niño if we have increasing temperature in North Atlantic. So I'm going to the final. We have challenges to be faced, like geographical distance, difference in education systems, administration. We sometimes FAPESP tell to us that we can do. The FG tell to us that it's not possible, and it's very complicated. We have different culture. It was a very, very, very interdisciplinary work where we have to understand what the climatologist said with some things that for us make sense, does not make sense, or they have some sense or scenario that for us does not, it's impossible. But we have joint research interest, we have a complementary expertise, we have a lot of motivated PIs, and the students, it was very, very, very strong. We have students from all over the world. And we have a strong support from Humboldt University, USP, INPE, all together, and the decision to strong support the FG and FAPESP. So FAPESP, all the time, we have a direct connection, and they told to us. For example, Rocato, I have sent several hundreds of emails to him. He always answers my emails. And we are not able to go with this project without him. Thank you so much. And we have a structured work with regular communication, video conference. At that time, we do not have Google Meet, annual workshops, schools and PhD students and so on. So that's a very interesting field trip on Amazon that people went there to see the Amazon and the other things. So it's that we have several papers on that, as you see. And with that, I'd like to thank you very much again. Thanks so much.
Thank you, Elbert, for showing the power of interdisciplinary research. You know, the beautiful science we can do if you put together neuroscientists, mathematicians, you know, earth science. I know that you showed just one of the aspects of your project, that is the earth science, but you have many other results from the other components. So that's very, very, very nice. So now we'll have the pleasure to hear Vincent from CNRS on changing a little bit this subject. Go ahead.
Okay. So, bom dia a todos. Thank you for inviting me for this event. So, I'm Vincent Vantrepotte. I'm going to speak about observation today because it's really crucial to have observation to monitor the impact of climate and human pressures on the ocean. And my work is a part of it. I'm using especially ocean color observation for monitoring the biochemical changes in the coastal and oceanic waters, especially in Brazil, through diverse collaborations. So just a very, very brief introduction slide. As we all know, the ocean is a key regulator of the climate, especially through its ability to pump carbon dioxide from the atmosphere and to store it into a deep ocean. What I wanted to show here with this figure is that this ability of the ocean to capture atmospheric CO2 is highly variable in space, so you have to develop regional studies. And what you can see as well is that all the coastal waters here in white is because we still have a lot of uncertainties on the role of the ocean, the coastal ocean, for the global carbon budget. So besides this, we have plenty of impact of climate change on the ocean, on both coastal waters and open ocean waters. I won't detail here all these four things, but what I wanted to underline here is that this impact on the ocean are diverse. They are acting at very different time scales, from global change to very coastal events. So we need to have observations. We are able to capture all the processes which are impacted by climate change. And so this needs to develop integrated studies, multidisciplinary studies for observing the ocean in order to feed the models which are making projection of impact of climate on the ocean. And my work is a part of this. My work is dealing more so to the development and use of ocean color observation for monitoring the impact of climate and the other pressures on the ocean. So what can bring ocean color remote sensing? So it can bring information about essential climate variables, so such as the water color itself or the phytoplankton biomass. But now, with many methodological developments, we are able to have much more information than this. We can have information about the community composition of phytoplankton, which is useful to assess the impact of climate on the marine diversity, let's say. And we can also have information on diverse key descriptors of the ocean carbon cycle, including information about primary production, so the biological pump of the ocean, information about important carbon stock in the ocean, such as the dissolved organic carbon and particulate organic carbon. And we can also have information about the PCO2 fluxes. So these kind of informations are crucial for improving the biochemical models used in Earth system models currently. So another interest of ocean color remote sensing and satellite in general is that it allows to cover a wide range of spatial and temporal scales. And for instance, we can have information on a very local scale on very specific coastal waters, such as estuaries, bay lagoons, etc. And we can have information at very small temporal scales about extreme events. But we can, at the same time, have information at global scale and information about the interannual changes related to climate modulations. So this is what I'm showing here. It was a former paper I did showing that ocean color, remote sensing, able to capture the modulations of the phytoplankton biomass induced by modulations of the climate forcings. So what we need really now, if you want to use ocean color for climate studies, is to have long-lasting time series of consistent data in order to be really able to assess what is the impact of climate change when compared to what is related to the natural variability. And so this has been performed through different projects, European projects, so the Ocean Color Climate Change Initiative and the project Globe Color, which have merged in the aim of having data reliable for climate studies, all the satellites currently available for ocean color. So this is a real improvement. We can have information about 25 years, since 1997 in continuous, about the ocean with daily data, and we can try to make this kind of trend analysis. What is missing still is to have this kind of data for coastal and shelf waters. We don't have this such long-lasting time series with satisfying accuracy now in these coastal and shelf waters, and we need to have a more detailed spatial resolution because these data are for now produced at 4-kilometer resolution, which is maybe not enough for capturing what is happening in the coastal ocean. So my work is related to this, to the use of ocean color and to the exploitation of the different potential that potential information that we can extract from ocean color. And so just to make a quick focus on Brazil, when you are working on the impact of climate of Brazil, you have to consider two things, two main things, let's say, what is happening at the ocean. So change in terms of ocean circulation, terms in change of water masses, vertical structure. But you also have to take into account what is happening in terms of modification of the climate regarding the land-sea interactions. So modification of the river runoff, for instance, or impact of extreme events. We already spoke about this in the previous talks. When trying to have information about the evolution of the Brazilian waters in terms of biogeochemical properties, we have also to consider other kind of impact, not only climate, but direct human impact, let's say, which are related to anthropization, industrialization, dam installation, intensive agriculture, and deforestation. Still, there are a huge need of developing studies for having a better understanding on how these different pressures are acting on Brazilian biogeochemical properties, and how maybe these different kind of pressures can have a combined effect on these waters. So in that respect, so ocean color is an adapted tool for different reasons. So when we are working on coastal and shelf water of Brazil, we have to face a challenge which is the extension of the Brazilian waters, so which is very difficult to follow with in situ measurements. So in that respect, ocean color is particularly useful. We can have a synoptic view of all the waters of Brazil. Ocean color has a sufficient precision in terms of resolution, spatio-temporal resolution, to capture the high heterogeneity in terms of physical and biochemical dynamics of the Brazilian waters. And ocean color can also help to have information which are not available in situ for now, since we have a lack in Brazil of long-lasting in situ biochemical measurements, even if there are some recent initiatives to develop this kind of measurements, which are essential. However, in order to use properly the potential offered by ocean color, we still have to work a little bit in order to improve the products over the Brazilian coastal environments, especially. And we need to have data with a spatial resolution relatively fine. Again, this kind of data are not provided now by any spatial agency for now. So my collaboration is Brazil. I enter into this general context, and so my main collaborator is Brazil is INPE, and in particular Milton Campbell, who is here today. And so we have started to work on regional approaches. For instance, dealing with the estimation of PCO2, it was very innovative parameter in the estimation of PCO2 in the water of the Amazon River. And then we move on, and now we are developing studies in order to have information about the whole Brazilian waters. And for this, we are not using regional approaches, but we are taking into account the variability in terms of optical properties of the Brazilian waters in order to deliver product over the whole Brazil. So the idea is to generate accurate ocean color data for the very, very turbid waters that we can have, for instance, in the Amazon plume, up to the very, very clear ones that we can have in some part of the Brazilian shelf. And for this, we need in situ data for developing and validating what you are estimating. So besides these developments really related to ocean color remote sensing, we have, through this collaboration, the opportunity to collaborate to interdisciplinary networks, which are needing ocean color data and which are helpful for us to understand the processes which are driving the variability that we are observing from space. And so the first project in which we are, structure in which we are collaborating is the Velitrop IRP, so it's a CNRS structure which is aiming to have information about carbon dynamics in the coastal waters, especially in the Bay of Rio, and with a specific focus on the impact of eutrophisation on the carbon fluxes, and with a specific focus on mangrove area as well. So beside this group, we are also having interdisciplinary studies using as input of ocean color, one of the input, in the northeast Brazil, through the Tapioca group, which is gathering something like, I think, 20 labs from France and Brazil, and which is in Recife. So it's an IRD structure. And in this case, we are using ocean color as an input for studying the impact of climate and human pressures on the structure and functioning of the whole north and northeast Brazil waters, having interaction with modelers and also with biologists, for instance. So just a summary of this collaboration in Brazil. We have a strong collaboration with INPE, and we are putting our force together to try to improve the observation of whole Brazilian waters using ocean color. This can be useful for plenty of applications. I would like to point out the necessity to have interdisciplinary studies in order to be able to study the response of marine Brazilian waters and marine waters in general to climate and human forcings. And this is a real important point, and ocean color can contribute to this. And what I would like to mention as well is that with my experience for now in Brazil, I think that there is a real need to facilitate and develop the use of ocean color observation, which potential is currently largely, according to me, underexploited in Brazil. So just to move on the future, so taking into account these lacks and the needs that we have identified, we recently submitted a project to the ANR FAPESP call, which is named COCOBRAS, and so I would like to take the opportunity to thank FAPESP for supporting this project. So this project is in between LOG, so my lab, INPE, and also the Institute of Oceanography of USP. And one of the main objectives of this project is to generate 25 years data set of ocean color descriptors, descriptors that we can have from ocean color at 1 kilometer resolution. So again, this is something that is not existing for now, which is not available for now. And so for doing this, we will rely on an extended in situ data set. Again, this is essential. And this data set is corresponding to data that we acquire ourselves, but it's also corresponding to data that we were able to gather through the collaborations that I mentioned before, for instance, as well. So meaning that it's important to have collaboration in that respect as well. So the information that we'll have will be on phytoplankton biomass. It will be useful for studying the carbon dynamics in the Brazilian waters, and also having information about the evolution of water quality, let's say, in general. So besides producing these data sets, we will also use different statistical tools to make analysis of the time series that we will generate. For this, we will specifically focus on different patterns of variability, focusing on episodic events, so potentially related to extreme climate events. We will have a better look on the seasonal variability, on phytoplankton phenology, for instance. And we will have a look on the long-term variability during the last 5 years in Brazil. And so the final goal will be to provide a clear diagnostic of the evolution of the Brazilian waters during the last 25 years, and to try to have clear information on the pressures which are responsible for the observed changes. So it's a project which has started some months ago. So I just here show preliminary results showing the kind of hotspots that we can find for now in Brazilian waters. So that's almost it. So as I was saying, it's a project which is beginning, but which are the expected outcomes? We really have this wish through and it's possible through the collaboration between INPE and LOG, which is very strong, to provide to the scientific community reliable information about the long-lasting variability of Brazilian biochemical properties. We will provide information to decision makers on the vulnerability of Brazilian waters, especially of coastal Brazilian waters. We have really the objective to develop within this project capacity building. So there will be different kind of student trainings. There are 2 PhD students involved in the project, And we also plan to make a different summer school with different teachers which are specialists of ocean color. And the first one will be next year in the marine station of Institute of Oceanography of USP. I think that, and believe, and I hope that this project will reinforce interdisciplinary studies, exploiting reliable ocean color data. So it will be performed in the frame of networks in which we are already involved, but I really wish to initiate new collaborations through this project. So that's it. Thank you.
Thank you very much, Vincent, for these interesting applications. That is very, very nice. So, and then we'll have the last speaker, that is Pedro Brancaleon, that will talk on silviculture, forest regeneration, and degradation of impacted areas. Pedro, go ahead.
Thank you, Paulo, for the introduction, and thank you all for attending this meeting. So I will be presenting here a project, a collaborative project with many European organizations and also with USP through the funding of FAPESP, which is called the Mixed for Change project, Mixed for Plantations, Forest Plantations for Climate Change, Mitigation, and Adaptation. So before I start, I'd like to convince you that this is an important topic. So all of you know that we are facing some very, challenges regarding to climate change. And the forestry sector is one of the central human activities involved with some of these impacts. So the forestry sector has a great potential to help mitigating climate change because, growing trees is one of the most cost-effective solutions to sequester carbon and help decreasing the atmospheric levels of CO2. But at the same time, the forestry sector may magnify some of the most important consequences of climate change. Because when we have droughts, for instance, the forest fires, they can become, disasters. They may displace people, destroy infrastructure, and destroy native ecosystems. And when we have a lot of biomass in regions submitted to extreme droughts, we increase the chances of having these problems. At the same time, when we grow trees, they demand a lot of water to grow. So we may increase problems of water shortage in catchments where we have large areas of timber plantations. And so the forestry sector is at the center of the recent debates on how to tackle climate change, not only as a potential solution, but also as a potential problem that is magnifying and increasing the consequences of climate change. I will give you some numbers of Brazil to illustrate how these questions, they are important. So in Brazil, we have around 10 million hectares of commercial timber plantations. 10 million hectares. Do you know how much percent of this area is covered by exotic species? 97%. 97. Around 78% is eucalypts, and the rest pine tree plantations. Let's talk about eucalypt plantations. Brazil, they are important. Brazil is the largest global exporter of pulp, and the timbers, the forestry sector represents 1.2% of the Brazilian GDP. So it's a very important economic sector. But when you consider eucalypt plantations, do you know how much water they can uptake when you have a young plantation? 3 to 4 years? Per hectare. No, it doesn't, let's say, let's rainfall. It's 1,300 millimeters. Do you know how much is the rain we have in our region? Around 1,300 millimeters. It means that these plantations may drink all of the water that rain brings to some catchments. So if you don't plan eucalypt plantations well, you may magnify some of the most important problems of climate change. And you know which is the new frontier of eucalypt plantations in Brazil? Mato Grosso do Sul, a region well known for having a seasonally dry climate. So, and let's talk about some potential solutions for it. So how could, we know the forestry sector is important, we continue to rely on it, but how could we help improving these problems? So we have seen that biodiversity is one potential leverage to resolve some of these problems, because more diverse forests, they are more resilient to climate change, they are more efficient in using environmental resources, and they benefit biodiversity. But let's talk now about the homogenization, biotic homogenization of Brazilian plantations. I talked that most of the plantations are made of exotic species, and particularly of eucalypts. Do you know how many eucalypt species we use here in Brazil for these industrial plantations? We have around 600 eucalypt plantations in the world. We use only 3 species. And around 70% of the eucalypt plantations in Brazil are established with, sorry, eucalypt companies. It is established with one clone. One single clone represents around 70% of the eucalypt plantations in Brazil. It's a major risk in times of climate change. So in this project, we aim to address some of these challenges using biodiversity as a key strategy for adapting the timber plantations to the 21st century to times of a changing climate. So this project is a big project. It's a coalition of different organizations that were collaborating before and got together to develop the Mix for Change project. So it involves universities from France, from Germany, from Sweden, from Belgium, from Brazil, but not only universities. So we have in this project some of the key like the key coalitions of the forestry sector working in these countries. So our goal is to promote the mixed species forest plantations as a nature-based solution to fight the causes and the consequences of climate change. So we are considering in this project not only the super diverse plantations that we have here in Brazil for restoring native ecosystems, but a kind of gradient of innovation for increasing the biological complexity of tree plantations. Sometimes we can mix clones of the same species to increase the resilience to climate change. Sometimes we may add one more species in the system. So there are many ways to increase the diversity of a forest plantation, and we are exploring it in the project. So this is the general overview of the Mix for Change project. So in the first work package, we are exploring how we can mitigate climate change with timber plantations. So we are exploring how we can increase carbon uptake by these tree plantations. In the second work package, we are exploring how we can better adapt to climate change. So we are especially focusing on how we can make these plantations more resilient to drought. So it's a critical problem in these plantations because the trees, they grow very fast, they demand a lot of water, and when we have an extreme drought, they die. So I have seen with my own eyes hundreds of hectares of like 3 to 4 years old eucalypt plantations died. They die because of the lack of water. And through time, the companies, they have, developed new cultivars and new plants to increase productivity, considering that there is no resource limitation. But now things have changed. These eucalypt cultivars, they are great for growing fast if you have water. When you don't have water, they dry, they die. So we have to make these plantations more resilient to climate change, and we are exploring how to make it. And we are also exploring the biotic interactions, like the mycorrhiza, how we can, and also pathogens. We have the insect, the bark beetle outbreaks, for instance, in Europe, that is also a consequence of climate change. Can you imagine if we have this kind of pests here in our eucalypt plantations? So it's also another important consequence to be addressed. But we are not only focusing on the research side of this project. We also aim to have an impact in the forestry sector, and that's why we are working with different stakeholder groups. And then, so this is more or less, and an important part of the project is to explore the stakeholders' perceptions on the potential alternatives to increase the diversity of the plantations of the forestry sector. So I have here Leticia, she's the postdoc, the PhD student of this project, and she's leading this component of the project. And I think I gave details about it before. So in this project, we had a chance to put together a large network of controlled experiments that are focused on understanding the impacts of tree diversity in ecosystem functioning. There is a well-famous network of experiments like this, the Tree Dive Net, which explores how adding species to the system increase the functioning ecosystem processes and functioning of your ecosystem. So it is critically important because it is a kind of hard test for important ecological theories. One of these theories is the biodiversity and ecosystem functioning. So the idea is that the more species you have in the system, the better is the function of your system, and the more resilient your system can be to changes. So one important scientific challenge of this kind of experiment is to separate the selection and the complementarity effect. So for instance, a monoculture can be very efficient depending on the species you choose. And a mixed plantation may not be so efficient depending on the species you choose. So an important challenge is to separate the selection effect, like the species you add to the system, to the way the species they interact with each other. And that's why there is a kind of complicated experimental design to disentangle the selection and complementarity effects, and that's why we cannot work with so many species. So usually what we have is like one monoculture of different species, and then we start the combinations, 2 by 2, 3 by 3, until we reach the higher diversity. So in this project, we combined experiments established in Austria, Sweden, Belgium, Germany, France, Brazil, Sweden, to have a global overview about how tree diversity may impact ecosystem services. And this is important because you know that climate will not change the same way everywhere. So having plots, controlled experiments in so many regions is important for us to have a global overview of how biodiversity can help us to tackle the most important challenges brought by climate change in different ecosystems. So here we have tropical forests, we have temperate forests, and many different types of forest ecosystems. So in this project in particular, I will describe here the mixed plantation of Brazil. I led this experiment. So it is a 30-hectare experiment. So part of it is composed of this tree diversity gradient. So this is our main playground. So I bring my scientific colleagues to play here in this very beautiful playground, at least for me. I really enjoy this playground. So what we have here is 2 experiments. The MetaDiv is this tree diversity experiment. It has 5 hectares, around 150 plots, because we need all of those combinations I mentioned. But we are also exploring 2 factors, nutrient limitation and water limitation. And we manipulate water to the trees by intercepting part of the rainfall that reaches the plots. So we can reduce the water available to these trees by 30%, simulating what could happen in a climate change scenario. But also we have the MetaFlux experiment, which is a 25 hectares area in which we have a flux tower to explore the flows of carbon, water, and energy. This is critically important because nowadays we try to understand the impacts of forests in climate change mitigation using very simplistic techniques like doing a forest inventory, using a generic equation to estimate biomass, but then we forget the soil, the flows, and how things change across time. So with this kind of equipment, the flux towers, I imagine Paulo will describe more his experience in the Amazon, we can have a very accurate estimate of how restoration may impact climate change and the flows of carbon and energy to the system. As far as I know, Paulo, I think this is the only restoration experiment with a flux tower. So, and this is one of the mega sites of the Mix for Change project because we can use this equipment to kind of calibrate some other measurements we have. And just to give you an overview, oh, I don't know what's going on here. Could you help me? I just would like to show the video. Yeah, I imagine you have to click on the center of the, so it's just a general view of the Mix for Change experiment in Brazil. So you see here the center, the flux tower, and you have an idea of the magnitude of the experiment, the 30 hectares of controlled experiments. Good, obrigado. So here's the flux tower, as I said, and then the controlled plots, some of the trees suffering with the drought, induced drought. Here, all of the controlled experiments, 150 plots, and then all of the restoration experiment. And this is our playground. And we bring our French and German friends to play here with us. So, as I said, we also have this social survey, understanding people perceptions on the challenges, because you may imagine there is a reason for using so little diversity in these systems. Basically, it's to industrialize the process, to make it homogeneous, and to make machines work better, and so on. So we are doing interviews in Brazil, in France, in Sweden, hopefully in other countries that Leticia may explore. And I would just present here a brief overview of the, as Paulo asked, some difficulties and synergies that we found in this project. So as part of the difficulties, I would highlight the funding for field experiments. So usually what we do is like all of the funding for establishing this big experiment didn't come from any funding agency, because usually they don't pay for this kind of experiment. They pay for the equipment, the scholarships. So I have to find my way to establish this experiment and then to have the opportunity to get the funding for studying this system. So just to have an idea, I got the areas for the university. So we quit using 50 hectares of eucalypts for hosting this experiment. And my department had a financial problem with this, but we resolved it. But then we got the seedlings from a private company, the plantation from the Bayer company, all of the cost of the tower with a Belgian NGO, and then finally we had the chance to do the research here. So also variations, you know, during the pandemic, currency and local prices. So the funding we had initially was not enough for covering many other expenses because of the changes of the prices. You know, the flow of biological mycorrhiza samples among countries is super complicated. And for Leticia, she had to do social survey in Sweden, in France, and many local stakeholders, they don't speak English, so it was also a challenge for this kind of survey. The short term of the project is only a 3 years project. And synergies, as I highlighted, we could explore with this project broader biophysical gradients, exploring different climatic events. So I know it was a problem for you in Europe for having this extreme drought, but for the project, it was amazing. So sorry for that, but for science, it was really good to explore our treatments in a so extreme climate. And also, it was possible to develop common scientific protocols to explore all of these experiments using the same strategies, the same protocols, and then it enabled us to compare the results. And finally, it was the seed for a long-term collaboration among these research groups. I'm sure that we will continue to collaborate in spite of the end of this project. And just a final idea. I think we have to invest more in a kind of green infrastructure for long-term ecological collaboration. The research agencies, they are mostly focused in buying equipment, in providing money for a scholarship, but we have limited opportunities for planting forests and start studying them after 5 years. Difficultly, people fund it. And usually, we have to get funding from private companies and find a way to establish this kind of long-term cooperation. So we have it for the CERN, the particle accelerator and other types of partnerships, but not for planting forests in experimental design for studying them in the future. Thank you all for your attention. Thank you.
Excellent. I would invite the panel to sit over the table. So I think especially on this last talk, we had a very good example of how science can help to solve major societal issues. Brazil has a commitment to reforest 12 million hectares until 2030. And the question is, how are we going to do that? Which plant species, you know, which infrastructure, and so on. So I think that you see a very good example on how science can actually help a lot the society to answer critical issues. And also we got 3 examples of a very large and broad perspectives in science for scientific cooperation with Germany and also France, you know. In 3 weeks from now, we'll have a German high altitude plane flying over Amazonia for 2 months. So it's coming. Finally, the pandemic was a problem for the aircraft to come to Brazil, and we will fly making a tomography of the atmospheric properties of Amazonia for 2 months, studying clouds, aerosol, greenhouse gases, and so on. So this is a kind of example that science without this partnership will be absolutely impossible. So, and then we open for the audience for questions, issues, comments, and so on. Thelma?
Yeah, okay, thanks. Thanks to all the presentations, and Pedro, thank you very much. I found it very interesting because it links very much to the adaptation I was talking about, restoration and so on. But what brings my attention very much, and I'm very happy that we are doing this kind of experiments, it's a pity that it's short-term. I think this should go for a long-term perspective. And why do I say that? Because when I talked in my talk about the carbon dioxide removal that is going to be necessary to compensate for the residual CO2, because, you know, especially in the energy, you're not going to be able to zero the CO2 emissions. So largely what, you know, internationally people are thinking of is large-scale reforestation, afforestation. Yeah. And this is I panic. I panic because well, it's not only the issue of reforestation and afforestation, it's large scale. And so the kind of experiment that your playground, it's extremely important to get us to understand better, you know, what should be done if you want to go that way. It's not in all parts of the world that reforestation is going to work. And IPCC is very clear about that. I think the tropics have a nice opportunity. Yeah. And because we have opportunities for this, opportunities for bioenergy as well, not only, you know, from feedstock, agriculture feedstocks, but also from cellulose. I think that we need to explore this opportunity in Brazil, because I am absolutely sure that we will need to go that way if we want to be able to help. So it was just a comment. I really appreciate it, and in a message also for a longer term research cooperation on this issue. It's not only for Brazil, it is for everyone if we want to limit global warming. So thank you very much, and I really appreciated the ocean and all the presentations on this respect. Thank you very much for the opportunity.
So I felt challenged as being a representative from a funding agency. And so we actually do have funding schemes for long-term and very ambitious projects. Those are the CEPID projects. We just launched a call for life sciences, which is currently under judgment. And so for that, you can no longer apply because it's already terminated. However, there will be a series of calls specifically for the life sciences only. And of course, on every, that's a topic that always comes for any funding agency. Well, I have this huge project, it's $100 million project, whatever, just to put a high figure. And I just completed my PhD, and of course, a just completed PhD will not be able to ask for 100 million, whatever, reais or dollars. But then there is sort of, let's say, staircase in which, as you produce evidence, you're able to request more funds, appropriate those funds, and do research. So I'm sure your group has already amassed a number of results which allow you and a group to request for, let's say, a longer-term project, yet with intermediary steps. And that's how large projects are set. It's for anyone, governments or funding agencies, it's always hard to, let's say, disburse funds with goals which are 10 years from now or 5 years from now. Those are possible for large pieces of equipment such as the CERN or the Sirius synchrotron. However, for projects, there will always be the request for intermediary steps, which could be from side projects with the perspective of achieving the longer term goals, which may require 5 or 10 years to, let's say, get completed. So the CPID, it's clearly a way to move. Another strategy is the Center for Science Development, CCD, which then it's in partnership with industry, whatever the company is, Klabin, Suzano, or whichever the partner is, and then they set a portion of the funds. FAPESP sets the other portion of the funds. Yesterday, we just approved a center on the Superior Council of FAPESP, which just from FAPESP involved 29 million reais. And from the other partners, altogether, it involves 162 million reais. So, long-term project. And it didn't materialize all of a sudden. It took more than a year. But it evolved and it got approved. So there are means. And so I'm proud to say that FAPESP would be glad to hear a proposal from your group or from any of the other groups.
Yeah, there is a question here.
Aqui. Será que está funcionando? Da Vila Pola from Unicamp. Thank you all for the nice talks. My question is to Pedro. My impression is that Brazilian farmers, they tend to prefer ready-to-go packets or packages for, in terms of land management. The species they will plant, the amount of fertilizer they will add. The question is if this is the intention of the project. In the end, you come up with, one or a few ready-to-go packages in terms of planting. And I know you didn't refer to this term in your presentation, but I would love to hear your opinion about afforestation.
David, thank you for your question. I just like to briefly respond to Professor Thelma and Professor Luiz. So I fully agree. I think we have a new commodity emerging. Carbon is a new commodity, and Brazil has a great potential to be the major global player of this new commodity. So we have to be aware it's not only about environment and, to make money at the global economy, selling a product and a service that many big industries, they want to buy today. So it's critical for, the Brazilian economy to invest in reforestation and better ways to doing it. So regarding Professor Luiz Eugênio, please, it was not a complaint. I'd like to be clear with it. And also, I know CPD, I'm part of a group that applied a great CPD being evaluated now, CPD project. The main issue is that it's challenging, I understand, even for FAPESP to fund, planting trees, investing, like, let's say, 1 million in buying seedlings, hiring people, planting the seedlings, and waiting for 3 years until you start doing any scientific evaluation in this area. You will not produce any paper, you have no student, so it's difficult to invest in this kind of research project. It's not the typical research funding that we have. So I think, I don't know, maybe we could explore, we have it for other types of long-term investments, but for establishing plantations, I think we can maybe develop better calls and more aligned to this. So regarding David's comment, I fully agree. The Brazilian farmers, they love packages, and full packages with anything, no gap. And what we aim to do here is to develop this kind of package, and but it's challenging. So I'm in USP, I'm professor of tropical silviculture, how to grow native tree species. And when the farmers, they ask me, hey, how long do I have to wait until I harvest my jequitibá native trees? I don't know. Nobody has done it commercially. The 40 years of research that we have for the forestry sector in Brazil, even with public funding, was dedicated to pine trees and eucalyptus. So all of the forestry schools, they dedicated their time and their energy to investigating exotic species. So we have almost no knowledge about how to grow well the native trees, how to fertilize them, how to control pests. So this is something to be developed, but I fully agree, we need the packages. They do not accept experiments on their lands. Regarding afforestation, it's complicated because you are aware of it. When people, tree planting is a sexy solution today. Everyone wants to plant tree seedlings everywhere, and this is the problem. Because some areas, they are not good for planting trees. Mm-hmm. We have native non-forest ecosystems. We have ecosystems vulnerable to drought. And so it's complicated. So we need to keep the enthusiasm, but bring more science to guide decisions, because today we have seen many problems caused by poorly planned afforestation projects.
We have a question from
Yes.
Nadej.
Thank you all for your presentations. Pedro, can you tell us more about your partners in France, and where did you do your experiments in France, please?
Okay. So our main partner there is CIHAD, and this is CIHAD, is it? Can you understand in France? Okay, French. And it's an interesting case because we have a partnership with CIHAD in my department. So we receive a CIHAD researcher for 3 years. So it's a kind of, it's a partner. It's a long-term partnership. And every 3 years, we receive a new CIHAD researcher to work with us in the department. And this project is started because of this partnership. So CIHAD is the main partner in this case. And the equipment for the tower came from CIHAD. This equipment was in Africa, and suddenly it was available, and we brought it to Brazil. But maybe Leticia, my PhD student, she was in France. And could you mention some of the partners that you interviewed, and mainly the local stakeholders and...
Some agencies that we could be there and study with other PhDs and then other professions there. And I have a list of a lot of them, but mainly from the government and the forestry agencies.
Yeah, the problem is that they have French names and I can't pronounce them. I can give you a list later on.
We have one question here, please.
I'm Daniela Toer from the German Center for Research and Innovation here in São Paulo. I want to thank all the speakers, including also Professor Thelma and Professor Paulo, and FAPESP and the consulates for the organization. It's a really interesting event. I was wondering when I heard Professor Elbert talking about the complex systems, because I quite agree with Professor Paulo about the importance not only of international cooperation, but on the interdisciplinary perspective. We have one very complex system, the web, being used to influence another complex system, the neurological system of people, to give very simple answers on reality, and attacking another complex system or the understanding on how climate change works. I think that's quite interesting what is going on there. And what is your opinion on that? And if you have, or what you have for a perspective or research on the web itself as a complex system. This is one question. The other question is to Professor Pedro on how, if you already have talked or communications not only on funding on your research with the companies, I don't know with whom you're working, Suzano, Melhoramentos, whatever, and if they are showing open to this kind of research and to invest in more than only going on with whatever is already being done. Thank you.
Thank you so much for your very challenging question. But the main issue is the following. We are just starting to understand how those complex systems that involves agent of agent that interacts in different layers have his dynamics, how it works. For example, brain. Brain, we have networks of networks that they interact inside this network and outside among the network. In related to web, to internet, and we are now getting information from that to make decisions. For example, I'm involved in the project, the UNIFESP project actually is in the CPG, that we are trying to track to keep the information from web to see when, for example, the next pandemic would happen, when the disease would happen, and out of the information get a network to provide us those scenarios to allow us to control, interact with them. And also, we wanted to influentiate the people that are related in this complicated or this involved network. For example, in this thing that we are seeing in this election, we have fake news, we have rumors, and other way around. Sometimes we wanted that one information flow as quick as possible. Our brain do that, and we are trying to develop, all the people in the world, some strategy just to allow, to control, to actually to push forward the information as fast as possible, or to send information to compensate another one that we don't want it to be spread. So what I can tell is that it's a very complex problem that we are trying to understand, but there is a lot of research until we're able to be able to handle properly. Actually, we are now in this century as we were in the next one related to quantum mechanics, to find out, to understand. And another very important issue is about social phenomena, right? I think that we need to go to this direction to find patterns to understand better. But very nice, very interesting issue.
Thank you for a question. In fact, the eucalypt companies, they are one of our main partners. So they collaborate closely in this project and others because they have the system we want to study. So just to give an example, so one of their demands was to find a way to restore the legal reserves. Legal reserves are areas they are obliged to restore to comply with the forest code, but they can have some economic use of it. So they must use native species, but not only native species. They can use eucalypts, for instance. So we established a 30 hectares experiment in 3 sites with them, intercropping eucalypts with native species as a middle-way solution to restore an ecosystem, but also to provide some income to them. So, and this system was super effective. So eucalyptus is harvested, and then you keep only the native species in the system. But with the money we harvest, we got from eucalypt, we could offset from 50 to 80% of the total cost of restoring the area. And now they have more than 1,000 hectares of this system restoring legal reserves in their lands. So, and also like in Leticia's work, we want to know the challenges for our industry to implement mixed plantations. So it doesn't matter if researchers develop solutions that doesn't have a good match with the machines they have, with operational procedures. So we are interviewing them. They are key critical stakeholders in the process to understand how we can readily apply the scientific solutions we are proposing to the way their system is structured.
Thank you to everybody. So it's 12:03, and then I think we do not have any question. Do you have a question, Christophe?
Thank you. This question is for Professor Vantrepotte. I wonder if we could explain more about how does it work, the evaluation of phytoplankton community from the satellites. It seems amazing that you can get this level of information. Yeah. And just and what would be the next frontier in collecting data in terms of data that you can evaluate from satellite information?
Okay, so thank you for your question. For phytoplankton groups, there are different kind of methods. Some are based on machine learning stuff. Others are taking into account really the modification of different groups on the optical properties. So we are taking the amount of chlorophyll, and we are simulating what you should have watercolor for this level of chlorophyll. And then we are comparing this with what you are observing for a specific phytoplankton group. And you have an anomaly. And using this anomaly, you are able to label, okay, this anomaly is related to this group, and this one is related to another one. So there are new developments about this to go to the species, but it's much more challenging, especially in diatoms. We have someone on our team who was doing this. And so, but it's there are things which are still in development for going further and to go from the group to a species. Then in terms of challenges that we have, I think they are different. The first one is what we are trying to do in another INR project, is to have PCO2 fluxes in coastal waters. This is not existing as well. These are things that we can estimate from space using SST in open ocean waters, but for coastal waters there is nothing existing about it. And so this is also a key challenge, because as I was saying, there is no information, we have still many uncertainties on the role of the coastal ocean. And so this is one of the challenges. And then we are also developing other products which are trying to have information of other key biochemical descriptors, such as the particulate organic nitrogen and things like this. There are still many developments possible from ocean color. So initially we started with chlorophyll, and with time we have now much more information than this.
Good that you have discussed, the two major issues concerning carbon balance over the ocean and over continental areas. So this is absolutely critical issue that science can contribute a lot, and we have to do it over the next 10 years. So basically, if there is no extra questions, so the people in the organizing committee shows that we have a lunch served here, and you'll be back at 2 o'clock for the biodiversity section on this discussion. Davila Paula is here. He will be one of our speakers this afternoon. So let's wait now for the discussion in the afternoon, as well as lunch is served outside. Thank you very much. Excelente, né?
No projeto? Ah, sim, temos.
I think we can just begin to be on time. So thank you very much for your presence. My name is Jean-Paul Metzger. So I think I'm the ideal person to speak here with a French name and a German surname. And I will talk, so the idea is to give some short introduction about biodiversity, and I will keep this to the FAPESP biodiversity research. And just after me, we will have 3 talks explaining in more detail what is going on in the cooperation between Germany, France, and FAPESP regarding biodiversity issues. So the idea with this initial presentation is much more to talk about the future. Once within the Biota FAPESP program, we have established a strategic plan, planning the actions that we want to support for the next 10 years. And I think that looking to the future will be nice to plan potential collaboration between Germany, France, and Brazil. And so I think that the talks just after will explain the experience and the lessons that we do have about ongoing and past collaboration. So, okay, so first of all, I think it's important to say that Brazil is one of the most important countries if we want to look at biodiversity issues. We do have between 15 and 20% of the biodiversity of the world. And I think that means 2 things. First, that we have a huge responsibility to maintain, to conserve this biodiversity. And second, that we need to use opportunities in using the biodiversity to think about how we can promote sustainable developments and how we can use this resource in a sustainable way. And I think also biodiversity is part of the solutions of several problems that we do have as climate adaptation and climate mitigation. So we do have, I'm really sorry I lost the presentation in the morning. I was in another event, but I can see that we do have a lot of synergies in the studies of biodiversity and climate change. And obviously, FAPESP is doing a lot about supporting biodiversity research, but I will just limit my window of results in the last 20 years. Once in 1999, we had the creation of this program, the Biota FAPESP program, which the main aim was to support biodiversity research. So both to understand, to map, and also to understand how we can use this biodiversity. So it's a huge program, maybe the most important program in Brazil supporting biodiversity research, and maybe in the world, or at least in the global south. I think Biota FAPESP is really an emergent and very important program. Just to give you a short timeline of the project, this project was, as I said before, was created in 1999, but as a response of the CBD, so of the Convention of Biodiversity, on the meeting that we had here in Rio de Janeiro in 1992. And from this meeting in Rio de Janeiro, the community in São Paulo state organized it by themselves, and then they propose a program to FAPESP. So the program was not created by FAPESP, it was a movement from the society, from the community society, that proposed this, and FAPESP then created this program. So we began in 1999. In 2001, we created a new journal, Biota Neotropica, which is until now, I think, one of the most important journal in Brazil, presenting scientific results, both from the program and outside the program. And we created some specific programs inside the Biota, as this Bioprospecta, which is a bioprospecting project or program within the Biota FAPESP. And also I think it's important to say that we not only act supporting research, but we also act supporting the state governments in planning, conservation and restoration and sustainable use of biodiversity. So we had this book that was published in 2006, which was done in collaboration with the government. So it's a co-production of knowledge, and it was immediately applied for public policy. After 10 years, we had this, well, that's not very, so we had a scientific plan that was published in 2010. This was published in Science, so in the journal Science. And from 2010 to 2020, I think we began to establish some collaboration with other countries, particularly, so it's my French accent with the R, particularly with NSF, so with US, with NWO, so the Netherlands, and with NERC in UK. But as you can see here, more recently, we had this collaboration with CESAB, SEBA. Jerome Chaves is here. I think maybe he will talk about this collaboration. So this is a code that was supported both by FAPESP and by FRB, so la Fondation pour la Recherche sur la Biodiversité. And so we are completely open to new international collaboration. And here we have some other data showing that Biota FAPESP is also worried about how we can disseminate, so outreach activities were also planned in these last 10 years. And just to say, I will talk much more about this new strategic plan that we developed along these last 1 or 2 years, which is the Biota 2030. I will talk later. So Biota FAPESP, as I said, is a very successful program, and we can see this looking at those numbers. So maybe they are not, I think it's an underestimation of the impact of the program, but we should have around 6,000 publications, 10,000 citations in different journals. We have a huge community of more than 1,200 researchers. The capacity building capacity of the program is huge, so we are training a new generation of scientists from more than undergraduate students, master students, and PhD students, postdocs, so a lot of people having training, doing sciences in biodiversity. The funding, it's huge also. This is only FAPESP funding, so around $8 million US in the last 20 years. The annual funding is around $4 to $5 million US. And now we have 94 grants, ongoing grants, so it's a living program. We have a lot of research being doing now. And these are only the grants. We have a lot of fellowships associated to those grants. So very good project, very living project. And just to give you an idea of the diversity of themes, of topics that we do within the Biota FAPESP program. So we have, since studies about biodiversity and functioning in coastal areas, we do have something similar regarding forest, tropical forest, and both Atlantic and Amazonian forest. We do have also projects more focused on the in the study of the socio-ecological systems, so integrating biological knowledge with socio-ecological and cultural knowledge. And we also do have some more applied projects as this one where the main aim was to support the application of the forest code within the state of São Paulo, and so deciding how we can implement this reserve offsetting rules, which is a huge challenge for us. So both challenge from the science side, but also in the applied side of the science. And this is a biased selection, so this is a project that I coordinated in the past about ecosystem service. So not only looking at the impact of peoples on natural system, but also looking on how these natural systems can bring benefits to humans. So this is just a broad overview of what we are doing here in the Biota FAPESP program. So the idea now is to talk much more about what we are planning to support in the next 10 years. So this was discussed within the steering committee of the Biota program, but in consultation with the community. So we had some webinars during the pandemics, and so that brought a lot of information that we used to plan this strategic plan. And so I will talk very fast about these plans, and I think that this figure is a synthetic view of what we are planning to do. So basically, we are selecting 5 main topics that we think it's crucial to fund in the next 10 years, which are related to collections, discovery, so more basic science, about developing the approach of synthesis science, innovation, and how we can use biodiversity for transformation. So these are the 5 basic topics that we want to support in the next 10 years. And obviously, those topics, they overlap between them, and they overlap with other cross-cutting topics as, for example, oceans, as restoration, and we have the UN decade of restoration and ocean. We have a lot of overlays and interaction with how biodiversity can interact with climate change actions. And obviously, all this is related to sustainable development, to the economy with low carbon, and also how the study on education of biodiversity can also help to understand the biodiversity and the social aspects. And here we can see which are the outcomes that we expect about the interaction of all those topics. So I'm sorry, the figure is in Portuguese, but I'm just trying to translate here. So obviously we have education, we have internationalization, public policy, outreach issues, training of people, and obviously creating new knowledge that can be applied or that can help to understand ecological process. So going on these 5 main topics, the first one is the biota collection. So the idea here is not only to act and to fund infrastructure for existing collection. We do have a lot of existing collection, very rich material, but we need to avoid those situations. And we had very recently some bad issues like this one, losing a lot of information that was collected along centuries, and we can lose this in few minutes. And so this is not acceptable. So the idea is not only to work on infrastructure, but also work in increasing the access to this biological collection by digitalization, for example, but also to promote the science using those kind of information. So this is the biota collection, very in few words. The biota discovery is much more about basic knowledge of evolution, functioning, structure, spatial distribution of biodiversity. So we need to know the patterns, we need to know the processes, we need to know the functioning and how disease relates to the service of those ecosystems. So this is the biota discovery main objective. The third one is the biota synthesis. So the idea here is try to promote an approach of creating new knowledge from information that already exists. And this is done traditionally in synthesis centers around the world, where they facilitate the work of working groups. And these working groups, they are heterogeneous, and the idea here is to stimulate this lateral, associative, and creative thinking. So trying to stimulate the interface between sciences, so interdisciplinarity approach or transdisciplinary approach, if we want also to put together actors from the society. So this is the biota synthesis, and I think this is in addition to the other ways of doing research. And just to say that we had last year an appel d'offres, an appel de projet, a call, that was a collaboration between CESAB, which is the French Synthesis Center in Montpellier, and FAPESP. And so we have this joint call. It was a quite small joint call, but I think it's the first step. And we select two projects, one much more related to ecosystem service on soils, so the fauna service. And for each project, we have a PI from Brazil and a PI in France, so Miguel Cooper here in Brazil, Jérôme Mathieu in France, and they will have meetings here in São Paulo and in Montpellier. And the other one is the network of fungus interaction in the nootropics. So Paulo Guimarães Jr. here in Brazil, Melanie Roy in France. And so I think we are doing a first step of collaboration with the French government, with FRB in particular. And the last main topic that I want the fourth one, is the biota for transformation. So thinking now that biodiversity is not only something that will be impacted by human activities, but is also something that we can use to provide solution and to provide ways for transformative change. So for transition, for sustainable transition. And this can be done thinking about transition, forest transition, or cities transitions, about agriculture transition. So how we can, in different systems, transform them in systems more sustainable, more resilient to change. And I'm sure that this could be done using biodiversity as a way to promote this transformative change. And finally, so the last topic this time, is to promote innovation from biodiversity. So as I said at the beginning, we have a huge biodiversity in Brazil, but we are not using this biodiversity to promote innovation. And I can say here not only innovation, thinking about bioproducts. So usually we think about pharmaceutical products, cosmetic products, or food products. So those products are important, but I think we also can use biodiversity for processes, for using ecosystem service, for example, as bio-whale, in a way that we can avoid flooding events due to climate change and so on. So we can do innovation both looking at the products and looking at the process. And we want to stimulate that. And so in our strategic plan, we do have already a schedule of calls and activities from 2022 to 2030 So we plan this, and I think now we know where we want to put energy year by year. And so I think this can facilitate the establishment of cooperation with other funding agencies from France and Germany and other countries. And last, I think so, it's important to remember that the Biota is only one thematic program within FAPESP. They do have other thematic programs, and we want to work in collaboration with those programs. So the climate change, Paulo is here, it's obviously key, a key partner. Bioenergy, it's another key partner, innovation, e-science, and public policy. So the idea is to work together in what we are calling a meta coordination inside FAPESP. Okay, and this plan is available online, so you can download it. For the moment, it's in Portuguese, I'm sorry, but we will translate. Jérôme will help me to translate in French. But we will translate at least in English, sure, and that's it. So you can check and make questions. Thank you very much. I don't know if I'm totally on time. So we can, I don't know, we can open for question now or have the three, what have I, okay. So if you do have some specific questions about this presentation, I'm happy to answer.
Yeah, thank you very much for the presentation. I have a more administrative question. So you showed us that you were interacting with different stakeholders, multi-level, multi-stakeholders, and also with different disciplines. How is this coordination work being done? Do you have specially trained coordinators for that? How do you prepare them to be like, are these science managers, are these research managers? Because we saw that outreach into society also with other stakeholders which are more from the private sector. I'm mostly interested in, have you anything developed with this, or is FAPESP thinking about something like this? Because I think it's a very important point which the universities and also in Germany we are looking very much to this point.
I think it's a very important point, and I don't think that inside FAPESP we are really thinking about that. So I think the discussion we do have inside FAPESP is how we can select interdisciplinary project, making panels of specialists, and so avoiding some biased evaluation that can be done by some specialists in one issue that will. But how to do this co-production, transdisciplinary science is not easy, and we are learning. What I can say immediately is that I do have one project that I'm coordinating inside with the funding of FAPESP, and so within this project we do have a team to facilitate the co-production, and this team do have some experience in facilitation. But I really believe that we do need to have some kind of training, more systematic training, and not only focus on one project, but maybe I don't know, a course or. But I share exactly the same worries that you mentioned. We do need that. We don't know how to do that as scientists. At least I don't know. and we need to make collaboration with people that can help us to achieve this kind of interactions.
Yeah, thank you.
And if German side can help us, it will be great.
And we want to learn as well.
Sorry.
I wanted to say, in France, we do have special courses that provides master degree for future manager in science degree. It's mostly paid I used to work for the CNRS, and we used to pay its European project engineer, and it's a 2-year course where young people are trying to develop a new project with administration, technology, and mostly private sectors. Also, how to develop projects that goes to innovation and takes money, and the management of that. So it's quite new in France, but it's starting to be a big problem for scientists to have those courses. So I think Germany should also develop some kind of courses like that, maybe Brazil too, I don't know. But we do have that mostly for European projects, which is really hard to get and lots of paperwork. That's scientists, it's not your work, and you don't need to spend lots of times and hours to just do paperwork for that. Just to try to answer that.
Great, thank you. Maybe any other last question or comment? If not, we can proceed. But if you do have, Jérôme.
Thank you. So, Jérôme Chef from CNRS. I have a question about the German-Brazil potential collaborations. I know there is a very ambitious German project called the Biodiversity Exploratories that has been going on for a long time too. And I was wondering whether you have established some collaborations already with them. It's funded by DFG.
I think not within the biota. I don't know if Christophe wants to... You heard? Or again, Jérôme.
This is the Biodiversity Exploratories. It's a project funded by DFG in Germany. And I was wondering whether there's been already some connections made between biota and this project from...
I think not within biota.
So I think there's two sides to this question. One is the biota side. I think Jean-Paul could answer better. What we, FAPESP, is working on is on integrating better the programs with the collaboration structure, which means that so far we haven't heard of this opportunity from our partners in DFG, and it's really key to have scientists inform DFG or us, in the case of biota, of opportunities that arise. So we'll be glad to facilitate those. So far, I think the answer is no from Jean-Paul's response. But it's definitely something we'd like to work on to be more specific and goal-driven in our collaborations.
Thank you, Jérôme. And maybe we can talk later. Yeah. Okay, so let's go to the other talks. So now I would like to call here David Lapola, he's from UNICAMP, from the Meteorological and Climate Research Applied to Agriculture Center. Thank you, David.
Okay, good afternoon, everyone. Hello, thanks for being here. Thanks for the organization for inviting me. I feel very honored having the opportunity to talk to you here. I want to talk about the Amazon FACE initiative as an example of the challenges to do research on biodiversity, relating it also to climate change. I will explain you in the next minutes what Amazon FACE is. But more in the bureaucratic side of the story, Amazon FACE is officially a research program of the Ministry of Science in Brazil, led by INPE in cooperation with UNICAMP, having the Technical University of Munich as the main German partner, and also the Met Office, the British Met Office, as a partner. It is a research program since 2014. Since then, we had some seed money from the Inter-American Development Bank, IDB, some small money from the ministry itself, some money from CAPES, but it was not before the last year when the British hosted the climate convention in their territory that they announced a very generous funding for the experiment, which was, and then a counterpart happened from Brasilia. It always works like that. The foreigners have to come and invest something, and then Brasilia reacts. But okay. Whoops. A little bit. Let's go now to the scientific side of the story. You probably heard about the Amazon tipping point. It was coined as this hypothesis was first coined as the Amazon forest dieback hypothesis. Exactly 23 years ago, it was by late November 1999 that the first article mentioning this hypothesis was published. There are a lot of subtleties in this story, but in a nutshell, if we have extreme climatic change in the Amazon, as the IPCC indicates on average, higher temperatures, reduction of rainfall, we could lose the climatic envelope to sustain a tropical forest as we have today. The hypothesis came from modeling. I put one example here. So the map on the left is more or less the extension of the forest, the vegetation in South America, but let's pay more attention to the Amazon there. This is a modeling exercise. The map in the middle is if we have only this severe climate change, okay, increase in temperature, reduction in rainfall. We would have something like a savanna, a dry forest, or even a non-analogous vegetation there that we don't have today. It comes then that this same modeling exercise, say, for 23 years now, that if we have something we call CO2 fertilization effect, which could also take the whole talk here to explain what it is, but if you remember from high school that plants need CO2, water, and light to make sugar and oxygen, right? So in theory, or as lab studies show us for tropical species, if you increase CO2, plants become more productive and can maybe accumulate more biomass. This is the knowledge we have inside these models today. So a strong existing CO2 fertilization effect. The problem, and then if it is indeed strong and existing, if there is a CO2 fertilization effect and it's strong, then in these simulations the forest kind of persists. So it counterbalances the bad effects of higher temperature and reduced rainfall. The problem is that we don't know if this CO2 fertilization effect exists in the tropics, how long it would last, how strong it is. And of course, you can imagine the knowledge has advanced a lot since 1999, but only in regards to modeling. We don't have field evidence, experimental evidence on the existence of this process. One of these studies that brought some advance on the modeling side of the story is this one here, in collaboration with the main partner from Germany. I regret to say, I didn't say this in the beginning, that we don't have French partners in the project yet. So this might be one of the reasons I'm here, right? But the main German partner, Professor Anja Hamig from the Technical University of Munich, we merged efforts, our two groups, and this article is a modeling exercise showing that if we have limitation of nutrients in the soil, as is found in 60% of the Amazonian soil, especially phosphorus, that is not very present, available in the Amazonian soils, then the CO2 fertilization would be, on average, half as strong as we previously thought in the same models. And depending on the model we use 14 different vegetation models in this article. In fact, it would be 0 in some of the models there. Coming to observational evidence, something we thought would happen in 2050. Now this part of the slide here is showing observational evidence. It's not modeling anymore, okay? Based on a network of forest plots where people have been monitoring tree growth, biomass levels for decades now in both African and Amazonian forests. If the line, so you see Africa in blue, Amazonia in red here. The two of them are on the positive side of the graph, meaning they have been acting as carbon sinks. So they are getting carbon from the atmosphere and accumulating on their biomass. But for the Amazon, differently from the African case, this carbon sink strength has reduced by 30% since the 90s. And one of the reasons for this, I won't stay too long here, but one hypothesis to explain this, see, they can't explain this for sure because this is not a controlled experiment. They are just observing what is there. But one hypothesis is that it has been a sink historically because of the increase in CO2 in the atmosphere, but this sink is saturating now, perhaps due to the lack of nutrients in the soil. Okay. There's no better way to test the existence of this CO2 fertilization effect if not with a FACE experiment. Nobody made up a better method to test that. And what it is, the FACE acronym stands for Free Air CO2 Enrichment. It's a whole ecosystem scale experiment. You encompass a fraction of the forest and submit it to a higher atmospheric concentration of CO2. In our case, these are very well done illustrations, okay? It's not photographs. We hope by early next year we'll be able to substitute this by photographs. So it's a system of towers in a circular fashion. These towers hang hollow tubes connected to a tank of pure CO2. In between them, there are, pneumatic valves and a computational system that mixes CO2 in the right amount we want. And the amount we want is 50% more than the current concentration in the atmosphere. And release this air enriched in CO2 to the forest inside here. The system is open, it's not a greenhouse, so we can imagine the amount of CO2 we need is considerable, but not absurd, okay? In each of the plots, we'll have this central tower to hang instruments and give access to some of the trees, but also a construction crane that will not only help building the towers, but also later on provide access to the researchers to, make measurements in the top canopy. And in fact, this will be the only cranes in the whole Amazon that will provide access to the top of the canopy. We are eliminating the exclusivity of the Smithsonian Institute in Panama that is the only crane in the neotropics. The intention is to have 6 plots, like in this other illustration. Half of them will be a treatment, so releasing air with high CO2, and the other 3 will be control, releasing only ambient air. The British fund is funding the construction of these 2 first plots here. It's scary. It's scary how, digging the holes and putting concrete in the forest, but it's something we've been fighting for 10 years to have this experiment, and other people in the past tried to do this even before that, and this is now happening. This is a problem not only of carbon. Not only of carbon. The previous slide we were talking about this carbon sink, but it's not only about carbon. If you think about this, I wouldn't like to use this term, but just to make the thing faster here, this is what is called the flying rivers, which in more formal way is the transport of humidity from the vegetation to the atmosphere that contributes to rain in the Amazon and sometimes of the year other regions of the South American subcontinent. When you increase CO2, there is a trend that plants transpire less. Okay, this is something you can measure at the leaf level. But if you upscale this from the leaf level to the whole tree, then to the canopy, into the basin, the whole basin, how this can change the water fluxes in the region and elsewhere. It's also a problem of biodiversity, and this is highlighted here, because this is the first phase experiment that happens in a biodiverse forest. The other experiments happened in planted forests in the US with 1 or 2 species only. And each circle like this encompasses about 50 trees, mature, tall trees. Of these 50 trees, we have about 49 different species. And if you go to the second plot, it will be the same. You will have other 49 different species. So in the end, in our 6 plots, we have more than 400 different species. It's a nightmare. Or it's an opportunity to, for the first time, understand how biodiversity plays, the role of biodiversity in changing something so crucial for an ecosystem like this, which is CO2. And maybe just to finish, FAPESP is not involved so far in funding as a core funder for this. There was a notion in the past that FAPESP couldn't fund the infrastructure, which we understood completely, but there's a proposal now under evaluation, a bilateral proposal, let's say a robust proposal to fund the science here between institutions in São Paulo and Germany, funded in São Paulo by FAPESP and the German side by the FG. The proposal, it took us 2 years to write the pre-proposal. There is 150 pages, the pre-proposal, and is under evaluation by the FG. FAPESP doesn't evaluate at this stage the pre-proposal. So if we get the green light there, perhaps FAPESP will get the full proposal in a few months. And a last word here. Why we are doing this? 2 reasons, or 3 reasons. One is to improve our knowledge of ecosystems, improve our projections of this tipping point, which per se would be good enough reasons to conduct this science. But of course, there is also a socioeconomic relevance here, which I didn't talk about in the previous slide. Imagine the region with 30 million people, many of them, if not to say all of them, depending on this forest, even those living in urban areas. What would be the socioeconomic impacts of this? So We also have a socioeconomic task in the project, trying to evaluate. I would even show this here. I'll leave you with this slide, just to show this connection between climate change, degradation of the Amazon forest, for example, the dieback or tipping point, and how this can cascade in many other sectors of the region's socioeconomy. Thank you so much for your attention.
Thank you, David. Let's call now Jérôme Chave. So Jérôme Chave is researcher from the Laboratoire d'évolution et diversité biologique.
Boa tarde. And well, happy birthday to FAPESP. So really great to be here and to just feeling the space between now and the loading of my presentation, to be given the opportunity to speak about. So the topic was biodiversity, and I'll covering a few points about biodiversity in the neotropics, of course, and this includes Brazil, but it also includes, as you'll see, French Guiana, where I've been working for the past 20-25 years. So this is what we're talking about, this very nice ecosystem, which is so great has such a great feeling. This is also a very important planetary challenge. Forests are associated to a lot of stakes for well-being and equity for humans, life and biodiversity, and the energy challenge, as we'll see, is very crucial to understanding in terms of forests. We've seen today already several times that forests have been thought of as nature-based solutions to the climate crisis, especially planted forests, because they store and this very efficiently store carbon. And so there's been many ways of proposing strategy for better storing carbon using forest plantations. But also, as Levi already said, there is a very good point to be made that forests are already helping us by storing a fraction of carbon already by themselves. And we believe this could be a combination of this famous fertilization effect or other effects that are taking place and that are really complicated to understand, and I will take this opportunity to salute the work that Devi and Henja are doing with this Amazon face experiment, because this is really unlocking one of the great challenges of our science today. But we should not forget that this challenge also comes with a historical burden. I put together a few numbers here to say that today the total amount of carbon that is stored in forest is equivalent to the total amount of carbon that we've already emitted by anthropogenic emissions. So this is just a way of saying that there is no way on earth that we will use forest as the single solution to the carbon problem. It will be doubling the cover of forests, and that's completely impossible. So this mitigation issue will be, at best, an add-up, but we need other strategies, and not only this strategy. Also, this historical burden comes with the recognition that most of this historical burden is due to the global north, and to especially to Europe and North America. And tropical countries have made up, in the past, only 7% of the emissions. And yet, the global south are the countries that are suffering the greatest burden today and the greatest risks of climate change. So in these terms, this is a matter of environmental and social justice to make sure that any carbon market and carbon credit system is equitable to the global south. Now, I'm borrowing this term from a famous paper. I think Paulo was a co-author of it 10 years ago, which say that the Amazon basin is in transition. This is both a threat and opportunity, of course, because a lot of people are working there, and this is not to say that we should contain any development in the Amazon. The Amazon is like any other places on the planet. It's changing, but it comes with some well-known threats, and those are deforestation, which are difficult to underestimate. Here is the well-known trajectories of deforestation over the Amazon, which have been changing and increasing recently. And there was great work being done by INPE to monitor this really carefully. There are some uncertainty and some disagreements between products, which are quite remarkable actually to see how little we know of this deforestation process, and also to acknowledge the fact that this deforestation is due to specifically to community-driven deforestation, especially in South America. And that is an important fact to keep in mind, that deforestation is not is independent of is going on independent and is a threat to a lot of processes going on over the Amazon. Aside from this, there is this climate crisis we've been talking about. And we tend to underestimate the land use change crisis and overestimate the climate change crisis. There are two aspects of the climate change crisis: the risk of an increased shift of the water cycle regime to a reduced moisture outflow, and this is driven by deforestation. These are classic papers by Colin Snowbray and others that date back to, and I think this may be the one hypothesis that has been rediscovered the most frequently in the history of Amazonian research. Dates back to, actually, according to Carlos Snowbray, to the 70s, where a lot of atmospheric scientists were puzzled by the water system in the Amazon. And the point here is that deforestation is coupled with the water cycle over this large area of the Amazon, and that deforestation may be triggering further deforestation because it is changing the climate. The other aspect is that we're witnessing more and more extreme climatic events, not only in France, like we've seen this morning in one address, not only in Europe, but in the Amazon too. The problem of the Amazon is that we don't have the same thermometer to quantify this. The best thermometer we have is actually the level of the Amazon, the Rio Negro river next to Manaus. It's been going on since 1901. This is the most ancient meteorological record of the climatic situation of the central Amazon. And this data from Giancarlo Espinosa's paper recently is showing that the number of massive flood events, so very wet events, as well as the number of very dry events, have been increasing dramatically over the past couple of decades. And so it's really important also to point out that it's not only about the droughts, it's also about the wet events that may be catastrophic or even more catastrophic than the drought events in some situations. Now, shifting gears now, I'd like to present one of the projects that have been started in 2011 by the French. I've led this for the past few years now, and it is, the intention is to, if you want to simplify, replicate the Biota program in French Guiana. And I'm only half kidding here, because when we were given the opportunity to write this program, we looked around for projects that were of the same scale as what we wanted to do. And the only example we found was the Biota program, which was already ongoing for 10 years. And so we looked at this pluridisciplinarity, and we asked ourselves, can we, as a French institutions, a group of French institutions, can we do something similar? So we got funding in 2011, and it's still ongoing. The budget is around, total budget is around 17 million euros now. And we intend this to continue this adventure for a long time. We wanted to provide research environment in French Guiana to advance research in biodiversity, set up a vibrant network of scientists, all actively involved in biodiversity research in Amazonia, and foster a long-term research capacity building. And we've heard a lot about capacity building because the questions we're asking about climate change and about biodiversity, they take a long time and they take long-term monitoring. So those aspects are key to all of us, and we intend to provide this an extra brick to the very well-established Brazilian system in French Guiana in collaboration. One concrete example of collaboration we've set up already was actually quite recently, was last year, and Jean-Paul already mentioned this joint proposal between SEBA and Biota and the federal project Symbiose that's funded by CNPK and the French research institution for biodiversity, the FRB. So our research program, our scientific vision is a bit of an overstatement, but we are working on observing biodiversity and biodiversity changes. So it's all about monitoring biodiversity and finding ways to do this. Methods like meta-barcoding, environmental DNA are new opportunities to do this in a repeatable way over the long term. We want also to explore the history of biodiversity, history in the long run, how biodiversity came about in the Amazon, but also in the short run, how humans have interacted with the Amazon forest to set up and to change, to modify its biodiversity. Something that we tend to forget, but it's a really active field of research at the interface between history and historical sciences and biodiversity sciences. And very importantly, we have Institut Pasteur as partner and the University of French Guiana, and they are actively involved in the health program. So biodiversity is also about diseases, in a sense. So we try to be integrative and take this One Health approach. Biodiversity response to global change is really what we are all interested here today, trying to understand how biodiversity will be responding to global change. And then we have a synthesis approach which we implemented partly through FRB and partly through other partnerships, like we have also established an agreement with the Colombian Instituto Humboldt in Bogota, and we're starting some collaboration to use the data we produced with others to provide better knowledge to intergovernmental processes like INPE. And of course, the science society interface is very important. So over French, the scale of our activity here is really French Guiana, and we're trying to foster this research. Now, what we've been doing, and I'll give you a glimpse of a few research projects we've been doing over the past few years, is to better quantify the risk of mortality for plants, especially trees, due to drought. So this is a recent paper that was published, including some data from French Guiana, but others, trying to look at the temporal patterns of mortality across forests in very well-documented forest plots and relate them to different environmental variables. And it was found, it's maybe not too surprising, that there is an increased mortality in those plots, and the drivers of this mortality are higher temperature, lower rainfall, and all the climate change metrics that we know already. We've also been looking at intact forest. Every pixel of this map here is a 25 by 25 kilometer pixel, which is mostly intact forest. It's never been really deforested, and so of course this is a very small subfraction of the Amazon forest. And we've looked into a radar signal at C-band and tried to explore how this signal over the past 30 years has changed. Has it increased or decreased? This radar signal is measuring the moisture level of the canopy, so really how moist the forest is. And what we found is a really clear trend of decline of the moisture, and a really also strong response to the massive drought events like the 2015 drought here, which is clearly represented, plus a seasonality that we all know about in this forest. So the bottom line here is that the forest tends to be slowly drying, even though it's still persistent. So Whether this is indicative of a trend toward this famous tipping point that everyone's talking about is still debatable because the trend is very slow, but we have observational data to quantify the response of tropical forests, especially in the Amazon. And I insist these are very strongly selected pixels with no deforestation in them or degradation in those pixels. Yeah, and I'll be really quick about this diagram because Davey already showed it. Amazonia plays a large role in the global carbon budget, and the question here I want to ask here, how do we really know that? We have been using a lot of modeling, but Davey told you that the trust we can place into modeling is at best limited. We have used eddy flux towers data in many places in central Amazon, but they are really localized. But the best knowledge we have now is simply permanent forest plots that we we measure every tree and we remeasure them 5 years later. So it's kind of low tech and really nice type of research. And by doing this, we can quantify the amount of this famous carbon sink of tropical forest, showing that there is indeed a sink of atmospheric carbon in the tropical forest, in the Amazonian forest, but this sink is slowly declining. And this is due not to a decline in the net primary productivity, but this is due rather to an increase in mortality, consistent with the previous results I was showing. All right. Now, shifting gears a little bit, a topic that is really important is how do we quantify, how do we measure those, what we may call essential biodiversity variables. There are many essential biodiversity variables, but some of them we can measure from space, so they're quite interesting. A very basic one is how tall is the canopy of the forest. And until quite recently, we didn't quite know that. Thanks to our colleagues from NASA who've sent this instrument on board the International Space Station, we now have this data from the JEDI instrument, which is a LiDAR, small, medium-sized footprint. And this is a result from the JEDI experiment. So you see some hollows here in the map because, obviously, because of the cloud problem in Amazon, which is a major one. And still, we have very interesting results. The canopy height of the central Amazon is lower than the eastern Amazon and southwestern Amazon, which is really quite interesting. People have been speculating about this, but when you look at it, you're in the forest, it's really, for one thing, it's difficult to guess how tall the forest is. And another thing is that we're talking about several thousand kilometers across. So, you know, this intuition is difficult to build here. So this is a really interesting thing. And the obvious second intention we would like to have, based on this data, is how much carbon can we infer from height? Well, this is a difficult job. Well, obviously, why do we want to know how much carbon there is in forest is because we are really interested in carbon, in storing carbon, and understanding the capacity of storing more carbon in the forest. So there is this new toy, which is a massive instrument being prepared as we speak by the European Space Agency. It's called Biomass. It's an Earth Explorer mission that was selected in 2013. And Biomass has been, is now planned for launch as to May 2024, finger crossed. This is a P-band radar, for the first one to be launched in space at this wavelength. And it will be a wall-to-wall coverage of above-ground biomass within 20% accuracy, we hope, and at 4-hectare scale. So every 4-hectare pixel across the planet will be covered. We will have some information from biomass every year. So it's really amazing advance. Now, obviously, this is just observation, and this is not measurement on the ground, so we should not place any trust in that. And this is something that cannot be overemphasized. Now, validating this forest carbon maps is the next challenge, and the validation comes with good ground data. And so we've launched this GeoTrees initiative, which is intend to set up a network, a global network of plots, permanent plots with high quality data based on the knowledge of our colleagues from the Smithsonian, Forest Geo, from forest plots, especially rainfall and Afritron in Africa, from TMFO, which is the Tropical Managed Forest Observatory. And this is under the umbrella of GEO, the Group of Earth Observation, and CEOS. And so it's a lot of acronyms, sorry about that. But this is, all of these partners are all acknowledge that this is very important to have good data. Now, we don't want only to reap the data from field projects and to use that as a validation. We want to go one step beyond. And the reason for this is that our foresight is over a decade. And we want to have good forest data in 10 years from now. And the best strategy to do this is to fund partners on the ground to measure the plots today and in 5 years and then in 10 years. It's not just about a quick check. We want really to enable scientists independent of grant cycles. And this is really a big challenge that we are trying to tackle now. And any willing collaborators are welcome in Brazil. We already are discussing with INPE, obviously, because it's a remote sensing project, but we'll try to be open to any other suggestions. Now, moving on quickly, how much time do you have? 5 minutes or? No? 3 minutes, okay, I'll move on. So, obviously, forests shelter a lot of biodiversity, and I was playing with numbers here because actually a student in my class a couple of weeks ago asked me, but really how many species are there? What's the proportion in the neotropics compared to tropical forests? So the dark green proportion here is neotropical biodiversity for these different groups of life forms. Light green is the rest of the tropics. And the gray is whatever non-tropical species exist. And you see that consistently, the neotropics take up a third to almost 50% of the diversity on the planet for groups like mammals, trees, birds, and so forth. So it's really amazing. This small area is encompassing so much biodiversity. Now, exactly how many tree species are in the Amazon, as you may know, is a real open challenge. A lot of people are debating about this because, well, we don't have enough knowledge. This is such a large area. And as Debbie was saying just before, if out of 50 trees, you have 49 species, the question is just statistical. How many trees do you have to sample to have some knowledge of how many species you have around? And the answer is many, so it's a lot of work, and you have to have a lot of botanical expertise, and expertise that is obviously dwindling now. So that's a main challenge, which explains why scientists are disagreeing from everything between 7,000 to 15,000 species. You pick your choice, but this is still a really fascinating debate. Now, the history of the Amazon has been unraveled by many projects. I want to emphasize project by a colleague or friend, Lucia Lohmann, who's been funded by FAPESP and in the Dimensions NSF FAPESP project. She's been contributing with her colleagues a lot to this question. This is an example of research we collaborated in, showing that the Amazon is a source of biodiversity to all other ecosystems based on the event of diversification we can quantify using phylogenetic trees over this area of the neotropics. So it's a very important result. But now, to finish, I wanted to show an example that's been in the textbooks for a long, long time. The idea is that the tropics, and tropical forests especially, are a cradle for diversification. And the specific hypothesis for plants is that there is more UV irradiance in the tropics, therefore a higher mutation rate, and therefore because the DNA mutates more, then you can create more species differently. There was Armen Taktahan, who was one of the famous botanists of the 60s and 70s, put this idea forward, one of the first one, but this has been discussed a lot. Now, what we can do now, And this is quite amazing, and we're doing this with LabXA by sequence full genomes of non-model species of trees. And we're asking the question of how many mutations there are inside this, inside the a single genome, by looking at the different, or how many heterozygote sites there is in the genome. And we've been doing this recently with two species, Decorenia guinensis, which is a FAPESP, and Sextonia rubra, which is a Lauraceae. We have the number of genes, we have mapped the number of genes, which is completely new for tree species in the Amazon. I believe those are the first draft genomes we have for tropical trees, Amazonian trees. And here is one of the results. It's very early results, it's unpublished. But those two lines here show how many mutations there are in these two tropical trees with respect to the frequency. So it's very difficult to understand that those are the very rare alleles, the very rare frequency, very rare mutation events here, and the quite frequent mutation events. So it's customary to look at the same level of mutation frequency. And here you see that those our two trees lie way below the three draft genomes we have for temperate trees. One of them is an oak, another is a fagus, and the third one I forgot, but all of them are from Europe. So actually, what we find here is that the mutation rates in those two tropical trees is lower than in temperate trees, which is completely opposite to what we thought. And so it's really quite interesting to see how this new type of genomics, full genome research could inform very old hypotheses about diversification in the tropics. With that, I'll finish with a few messages. Forests offer great opportunities for mitigating the climate crisis, as I said before. Keeping forests healthy will be definitely a difficult challenge, and we have to take into account not only the climate change problem, but also land use change, and I think we're all aware of this problem here. And then the extent to which biodiversity will adapt to the changing worlds is really related to its evolutionary potential, and unraveling this question is related to understanding better the genetic basis for this adaptive potential. And I think this is one area where we can make the most progress in the years to come based on the advances on genomics. And I finish by saying in the neotropics, the major scientific discoveries rest on long-term monitoring programs at permanent forest stations. The stations are irreplaceable, and they need coordinated support from funding bodies. And I think I cannot end with a better conclusion here, and except for saying that, of course, we also need to engage citizens in the study of biodiversity and train the younger to understand how precious and rich observing biodiversity can become as a training facility. With this, I'll thank you very much for your attention. Sorry for being over time.
Thank you, Jérôme, for this amazing presentation. Now we do have Christiana Arduin. She's from UNIFESP, from the lab on host and microbe interaction. Welcome, Christiane.
Good afternoon, everybody. It's an honor to be here. So we are going to shift completely the habitat that you are talking. I'm going to present some results from a young investigator project that deals with spongia holobiome. So I hope in the end of this talk you know how wonderful these interactions are, as we are talking a lot about plants, so let's shift a bit. So first of all, they belong to the phylum Porifera, so it's the most metazoan animal that we have nowadays on Earth. All these species are found in Brazil, so you can see they have different shapes, sizes, and colors. They are sessile, so if you remember the talk that Thelma told us this morning, is that some animals on the marine environment, they are changing their habitat, so they are moving around to get a more comfortable temperature. But for the sponge, it's not possible. They have to deal with it because they are sessile. And I hope my video will work now. Please. They are an amazing filter feeders, as they cannot move, so they have to find a way to filter, to get food, so they are filter feeders. And we have probably a species in the Caribbean.
To make the invisible visible, Diaz injects a harmless colored dye into the water near the body of a sponge.
One of the ways we can test for the rate of water flow that moves through the sponge body is to inject a colored dye and measure the speed at which it is pumped through the sponge.
I will change because I put 2 movies because I didn't know how one will work, so let's move. So there are very few places where we cannot find sponges. It's in gray in the map. And some areas that are hotspots of sponge diversity. And as you can see, we have sponges in the Brazilian coast. And why do we study these animals? Not only because they are the oldest, they date back around 700 million years ago, but they are also able to associate with enormous amount of microorganisms. In this case, every dot, colorful dot, is a bacterial cell. So you have an idea how abundant it is. And I know that's bacteria because you use probes to get this image. And in blue, we see the fibers and filaments that help sponges to keep their structure. So the most comprehensive study done so far was published in 2016. They work with 81 sponge species, and because they are filter feeders, we also collect seawater and sediment, that's normal. So they end up with almost 4,000 operational taxonomic units. It's the closest to species that we have when we are working with molecular biology. So those are affiliated with almost 41 phyla, and they show high host specificity. But 99% of the knowledge that we have regarding the spongiolo biome are about bacteria and their archaea. How about the other microeukaryote? So this is a review that we recently published. So we have very few information, especially regarding the protists. But even if it is very little information, we know that, for instance, protists are able to perform photosynthesis, so provide food for the host and for the other members of the microbiome. And they are also able to produce secondary metabolites that can be involved in chemical defense, cell signaling, among other functions. And but most of the studies were collect sponges in these areas, all the orange yellow. So in South America, and especially in Brazil, there was any species that was collected. It's because we don't have, I already gave a spoil, but we have a bit more than 600 sponge species, and we have 125 species that are endemic. So we can do a lot of work here. So to try to fill the gap, and that's why one of the main objectives of the investigator project is to fill the gap regarding the spongiolo biome. So we targeted the 3 domains of life, prokaryotic, fungi, and unicellular eukaryotic, in 3 sponge species. It's important to tell you that Aplesinia caesarea is endemic from the Brazilian coast. We also collect seawater and sediment, and these samples were collected in Praia Preta, that's north littoral of São Paulo. So first of all, we have the 3 domains of life, prokaryotic, fungi, and unicellular eukaryotic. And the first thing we notice in this bar chart is that the community associated with sponges are really different from the seawater. But what's more surprising than that is that in the stars, in all the 3 domains of life, I'm highlighting what we could only identify at the domain level. So we don't know which phyla they belong. So the sponges are rich reservoir of novel microbial diversity in Brazil. And when you talk about, it's supposed to be 3 Venn diagrams, but okay. When you talk about how specific this community is, in some species we have at least 50% of their species that are only associated with this sponge species. So it shows a high specificity of this community. And then we want to know which are the processes that make possible the assembly of this community. So for the prokaryotic community, they are mainly deterministic process. And when you look for the microeukaryota, we have a more influence of stochastic processes by chance. They acquire the microorganism by chance. While in deterministic, you have some characteristics from the host that are responsible to acquire this microbiome. So another way to classify sponges, besides the taxonomy that I always say to everybody, I'm not a taxonomist. So we can classify them basically regarding their abundance. So there are two groups of sponges, and this study started in 1977, when some research detected around 38% of the wet weight of a sponge was composed by bacterial cells, by microorganisms. And how is that? Here's a transmission electron microscopy image. So you have all the cells are bacterial cells, so they are really, really abundant in the sponge body. And you have the low microabundance sponges, where you almost never get a bacterial cell on it. It's very rare to see. So we also wanted to know how are the Brazilian sponges classified in this regard. So we did transmission electron microscopy analysis as well. We see the two aplyzinias. There are a lot of microbial cells. When you look for the other 5 sponge species, we were lucky enough to get one bacteria here duplicating, but it's the only one in all the species. So we have clearly that Aplyzinia caesarea and Aplyzinia fulva are high microabundance sponges, and all the others are low microabundance sponges. Apart from Tedania, these were classified for the first time. And when we look for the beta diversity, we see a group here with both Aplyzinia species, and Sinachirella locata. The name is wrong here, I'm sorry. And we didn't manage to collect this because of the pandemic, so we have to believe in the microbiome data. They form a robust cluster, so we have all high microabundance sponges here, and all the low microabundance sponges are scattered around the graph. And we want to know which are the characteristics of each one, which phyla is reached in each type. So we perform an analysis and detect these phyla that are enriched in the low microabundance sponges, and only the one with the asterisks was previously detected in others LMA. The same happened for the HML. So you have 11 phyla, only 5 were previously detected. So even when you look at this bigger picture of the abundance, we have phyla that were reached in the Brazil sponge that were not detected before. So still, we have novelty here as well. And when you look for how the microbiome is assembled, we have less effect of stochastic in LMA than in HMA, and it makes sense. If you have a less abundance of microorganisms, it's easier to get what are needed. So the host gets only filters and keep aside beyond what they need. And it's easier to control. So by chance, it's very rare that you see a bacterial cell in here when we compare with the other one. When you have a lot of bacteria, so some of them will be associated by chance. So there are quite some works with both status of the sponges, and we can see that what was new in the literature are not applied for the Brazil sponge. So we have an amazing model to work here in Brazil. Now I'm going to show very briefly some works or studies that are going on now. The first one, normally when you talk about sponges, we think about the marine ones. But we also have freshwater sponges. So I'm showing trees. I'm not crazy. And all these black puffs here are sponges. They are freshwater sponges. They grow on trees and sometimes on holes in the rocks. And of course, we want to know how this what happened during this colonization from marine to freshwater environment. So we were able to collect 2 sponge species that are in green here, one from Rondônia and another from Recife. And you have these 2, Amphimedon viridis and Heliclona melana, that are a sister group from the freshwater, and another group that's Sinacirella. So when you look at the beta diversity, we see that indeed Sinacirella is an outgroup, but in this part, we can see that freshwater and the marine sister group together. So looking at the community composition, we see there are more freshwater sponges are more similar to the marine sisters than with the outgroup. So what you can say with the results that we have so far is that during the colonization process, bacteria were replaced when they went from the marine to the freshwater because the needs for the host was different because you have a completely different environment. Marine and freshwater are completely different. But somehow, at least some members of this, the marine, some bacteria associated with the marine went with the sponge to the freshwater and it was conserved, but their relationship changed a bit because of the challenge that the new environment provides. Another study also looked for the biodiversity, for the biotechnological potential. So we also isolated microbial cells, in this case bacteria. It's a very common cultivation procedure. And we have mainly 4 phyla that we were able to recover from the agar plates. And usually, when you do a cultivation approach, you get this phyla. So here there is no news. What was different is that it was a study performed by my undergrad student. She performed antimicrobial activity test, and we have here the strains from marine sponge, from Plisenia caissara. And here we have 2 indicators that are gram-positive, it's Staphylococcus aureus and the Pseudomonas aeruginosa, and 2 negative, that is Escherichia coli and Enterobacter faecium. Usually, when you perform these tests, what we have is that gram-positive bacteria are inhibit the growth of gram-negative bacteria. But here what we see is that gram-positive was effective against gram-positive bacteria as well. So we are curious about what's going on there, and we just wait the results from this analysis. So we select some of the bacteria strains and perform an analysis to know what compounds they are able to produce and get an idea, a real idea of their biotechnological potential. So another former master students made the molecular screens of these 2 genes, that's polypeptide synthase and non-ribosomal peptide synthase. They are known to be cytotoxic compounds, responsible for cytotoxic compounds. So we have the normal cultivation procedure. She got a higher number of bacterial strains. The association is basically the same that we saw before. More than half of it is Firmicutes. And we have alpha protobacteria, gamma protobacteria, bacteroidetes, and actinobacteriota. But what's more surprising when you look at this data is that even if it's a very simple cultivation procedure and media used as well, we have about 18% of new bacterial genera and 82% of new species. So even when we do a very limited approach, that's the cultivation, you usually get only about 1% of the community composition in plates, in culture, and we still manage to get this amount of new diversity. Then she performed the molecular screening for the genes. We have the vast majority of bacteria were positive for only 1 gene, which is normal. Very few were positive for 2 genes, and you have 1 extraordinary that was positive for the 3 genes. Usually also is that the PKS type 2, we rarely see in the bacteria isolated from marine sponges. So this is another plus that we got in our data sets. Then, because they are cytotoxic, we perform a biological test with the cytotoxicity against a cancer cell. And we were very disappointed with these results, because only one bacteria showed the capacity to inhibit the growth of the cancer cells. But we are not very satisfied with these results. So we selected all the bacteria to check about the compounds that they are able to produce. And in this case, each bacteria was grown in 2 media. So we also want to know if the same compound can be produced by the bacteria in both media or not. And we're just waiting the results from this test. We also have the genome. So now we are looking for a master student to perform the analysis together with Dr. Gustavo Gregoras, that's a professor at UNIFESP Baixada Santista. And now Liv is in the audience. Last week she went to the Sponge Conference in the Netherlands and provided a talk, part of her results, that now we are moving to the anthropogenic effect. So she wants to investigate the effects on the microbial community structure of Hymenaias deleophila exposed to diethylphenyl phthalate. I probably said wrong the name, but phthalate is used in the manufacture of plastic. And you are aware of the problems we have with plastic and microplastics in terrestrial and even more in the oceans. So what she did, she used 3 concentrations of phthalate. It was an aquarium experiment. So she used the 3 concentrations, and we have the control as well, and the exposure for 4 hours. But it's a very short period of time. But even then, we note some difference in the community structure. Okay. We have increased, I'm only highlight the proteobacteria, because we know now that there are some strains of proteobacteria that are able to degrade the phthalate. So in the control, we have increasing. In 2 concentrations, there was a decrease, and then in high concentration, we have a slight increase. So we need to look with more details to see if you find phthalate degrade bacteria that will help us to understand these results. So looking at the biodiversity, as we increase the concentration, we also is able to see the difference in the community from the control and the treatment. Oops. So I will talk very briefly, I promise you. One last part that was a big challenge for the Young Investigator project was perform an experiment with climate change. So we have a Plesinia caissara, that you know that's HML, and also Dragmasta reticulata, that's LML. So we went to the Guaicá, also in the North Litoral of São Paulo. Collect both samples, brought to the laboratory, and we decided to use 2 scenarios, future scenarios of the IPCC of this year. So with increase in 1.4 and 1.8 degrees Celsius. So we have the aquarium structure, so we have the 4 replicates of control, and then 4 of 1.4, increase of 1.4 degrees, increase of 1.9 degrees. And in the middle of the experiment, most fun part. Go back. In the middle of the experiment, you are joking. In the middle of the experiment, I started to note some bubbles on the Plesinia caissara with the increase of 1.4 degrees Celsius, and some depressions that they were brownish, but I could not see this in Dragmasta reticulata. So we have the metabarcode data, we just need to analyze it. We waited to the update from the data set. So hopefully we will be able to know what's happening with the sponge, because it's the intermediate temperature. I wasn't expect that. With that, of course, I would not have done even half of it alone, so I have a lot of people to thank you for their support and assistance, and thank you for your time.
Thank you, Cristiane. I will invite all speakers to join me at the table. Okay, so we had, I think, very nice presentation showing the result of some collaboration, and the idea now is to discuss based on these lessons that we had with past collaboration, so how we can foster and stimulate a new collaboration between Germany, France, and FAPESP. So the floor is open for questions or for comments from people in the table.
Thank you very much. My name is Ariel. I'm finishing my undergraduate degree at USP. That is the environmental management degree. I would like to make two different questions. The first one is related to the research in Amazon with the construction of the towers. I would like to know about how the areas were chosen, and if the study is looking to study these areas and look if the results are made for all the Amazon or just a specific area, considering the different characteristics of the different places in the Amazon. And the second question is related to the sponges as well. I didn't know that we had freshwater sponges, and I would like to know if it was studied what is the efficiency of the sponges to treat and filter chemicals in the water as contaminations like in the Rio Doce basin. Like if it would be possible to use the sponges to treat chemical contamination in the basin and in the coast.
Hello. Okay. So answering the first question, the place was chosen because it's. Sorry, I didn't have the time to tell you exactly where the experiment is located. It's in a research area that belongs to INPE. It's about 70 kilometers north of Manaus. And this patch of forest is perhaps the most studied Amazon forest in the whole basin, because it has been studied before by the LBA project. Paulo has been involved in research there as well. But the very exact spot, the exact plateau where the experiment is located was used before in it's not an experiment, but a project by Professor Niro Iguchi at INPE. And he has been monitoring the trees in that plateau since the mid-90s. And this pre-treatment data is precious for this kind of experiment. So we know it's like a patient that will go through a surgery, and you monitor his vital signs before the surgery itself. So we have this pre-treatment data is important. And the upscaling to other areas. This is the most asked question about Amazon face, because it's really localized, and how can we upscale this to other areas? First, for example, the soils of the area, they are representative of about 60% of the soils in the Amazon. But that's not enough with the huge taxonomic diversity we have. But something we don't know is the functional diversity of these forests. And this may be our focus there. If we focus on taxonomic diversity there, forget it. The experiment won't be relevant to say if this genera, this family will behave this way or that way with high CO2. But in functional terms, it can be you have species in quite different families, but they are functionally similar. This is a bit more complex than I'm trying to explain you, because functionality also has different perspectives. It can be functionality in terms of growth, in terms of how the tree deals with water, So, to resume, we'll be looking at the ecophysiological processes, like photosynthesis, transpiration, and trying to classify these processes as they happen in functional groups in the forest. Having these functional groups in our hands, then we might be able, or better positioned to upscale the results of this very localized experiment to a wider area. Not sure if I convinced you, but we can talk more later if necessary.
I'm sorry. Thank you for your question. Actually, very few people know about the freshwater sponges. There's only one family with very few species. The marine ones can be used as a bioindicator, but the problem with freshwater ones is that when you have the drought, they die. You only have the gems, so it's not possible to use as biocontrol for anything. And so marine ones you can use, they are known to bioaccumulate heavy metals, even some petroleum and other toxic compounds, but for the freshwater ones, it's not possible to do it, unfortunately.
Hello, my name is Tomás Domingues from USP Ribeirão Preto. Often we can see calls for proposals in specific agendas, such as long-term monitoring or synthesis. And I was wondering if it's something that the three countries here could act together and put together calls for ecosystem experiments. You see, David showed one example. Pedro Brancalhão, which is left, I think, showed another. And it's, in ecology, it has to deal with long-term. And especially if you're working with trees, a kind of vegetation that grows slowly. So maybe one way of interacting or fostering more interactions within the countries might be putting together calls on ecosystem experiments. So I would like to know if what the panel thinks about that. Thank you.
Thank you, Thomas, for your question. I wanted to take this opportunity, maybe not answer this question, but inform that the European Union has no European research infrastructure called ANAE, and this is for analysis of ecosystem and environments. This is a structure that is now validated as a European infrastructure for the long term. This is the equivalent of ICOS for eddy-flux towers, and the purpose of this infrastructure is to support environmental ecosystem experiment, exactly like you were suggesting. So I have no idea whether there are some agreements between, say, FAPESP and EU in that respect, but it would be an interesting way forward. I know that we have had some preliminary discussions with a group of people in Sao Paulo State, including Jean-Paul and Professor Carlo Joly, but it would be interesting to discuss this further. Thank you.
Just to say, Thomas, that I think it is an excellent idea, and maybe we need to resume the discussion that we had. I think Christophe was involved 1 year, 2 years ago in the middle of the pandemics, but this could be a good opportunity to work together in collaboration with this experimental approach.
Olá, eu sou Christophe Albuquerque, eu sou da FAPESP, acho que já falei antes. Eu queria comentar primeiro que essa mesa, como a mesa anterior, mas eu acho que essa mesa teve esse aspecto de ter uma estrutura muito bem organizada, de começar com a apresentação da estratégia do biota Perdão?
Maybe in English.
Oh, I'm sorry. I haven't realized I was speaking Portuguese. Sorry. So these presentations were started with the presentation of strategy, and then moved on to and I think that Jerome moved on from strategy to actual data. And what we have observed here is that there is a huge variety of research on biodiversity in its many aspects. And that research has been pursued to some extent in coordination among our countries or different organizations. But to a large extent, there's still a huge potential for coordination of this effort. So recently, FAPESP has helped launch or sponsored the launch of an initiative which we call the Amazon Plus 10 initiative, which aims to coordinate research that will result in eventually solving the conundrum of how to develop, provide human development in the Amazon without compromising the environment, and in fact protecting and perhaps recovering it. And this is perhaps a good framework to use to establish this coordination. So as a follow-up to this launch, my area, what I do at FAPESP is I work with the collaborations of FAPESP, and I've been talking to a number of potential partners on what we could do together with the Amazon. And what I lack is actually a central coordination effort that can tell these potential partners where they could join in and how this effort could add up to a common effort. How we can plug in different aspects of biodiversity research, which are all equally important. So I think that Christina's work has showed the importance, for instance, of the microbiome, and we hear a lot of microbiome in the soil, but microbiome in the sponges, which is another topic that is perhaps not broadly discussed, and I think that she was the main representative of that here. So how do we add all these components together? And I think that Biota has done a lot of work by establishing a strategic plan, but now we need that strategic plan to be broadened and to reach the whole collective of countries and agencies that are funding or pursuing research in the Amazon.
May I maybe provoke Paulo, Artaxo? Because I was not here in the morning, but I would like to know how the discussion that you had in the morning could be linked to those discussions that we have now with biodiversity. And so how you see this collaboration between the climate program and the Biota program?
Yeah, I think everybody who saw the presentation this morning saw that they are absolutely linked. Almost, what was presented on the Amazon Face experience could be either in the morning or in the afternoon. And that's a very good signal. I think that's very clear that the agenda of climate change and preserving biodiversity is converging. This is happening not just in FAPESP programs, but actually also in international meetings. We see this movement very clearly, and that is very positive. Of course, we need the public policies that could address both issues, in a good way, So actually, one emphasizing the need for the other, and vice versa. And I think this will take some time. Because, the lethargy of the global system is very, very large. But I think that's the way to go, and I think that's the way we'll see, let's say, this discussion starting COP27 after the COP of biodiversity, that will be very close together. And then this will pave the way for next year and the following years, to establish a joint strategy for mitigating climate change and at the same time preserving biodiversity. And I think that FAPESP program is already giving the first shot on this issue on the right direction.
Great. I don't know if French consulate or German consulate want to comment. That's good. Is there any other question of someone from the table here that want to?
I don't know if I didn't get it, but at FAPESP you had this co-funding line with the European Union, which was quite well established, especially within Horizon 2020, but I was just scrolling through the website and I didn't find anything regarding to Horizon Europe, and you're smiling because you know the answer, but I was just wondering, especially when we speak about the limitations when it comes to bilateral, and when it goes to trilateral, it gets much more complicated, and multilateral even worse, I would say, or even more challenging, to use a positive word for it. I was just wondering if there's any initiative within FAPESP to, if we see these different projects here, we see not just bilateral or trilateral funding agency approach, but maybe a more European approach to it within Horizon Europe. I don't know if you were in contact with them, and I still saw that the agreement, I think, is still valid. But maybe you could elaborate a little bit on that, because this is maybe a possible future to this multilateral collaborations, and not to have, I would say, in German we say like a Flickenteppich, like where you just put the bits and pieces from different funding agencies, and it gets rather complicated, and to have a European partner in it, and to involve our colleagues from French Guinea, from France, and also from other colleagues. But maybe Christophe, you have an answer to that?
Sure. So in terms of collaboration, I think that it's best to have a portfolio that includes from bilateral collaborations all the way to multilateral collaborations. And there's a number of reasons for that. So first of all, bilateral collaborations are great for building trust among the partners. And also, they allow the partners to set the goals of the collaboration very specifically. So when we join an European community, a Horizon Europe call, we usually join the call, so we don't decide the topic of the call. So we have more flexibility when we participate in setting up the collaboration. On the other hand, the Horizon Europe calls are very valuable and very valued by the community. So I think that they work together to build and to a dialogue and a portfolio of actions. Also, I would say that no scientist would be that happy if you said, okay, now you only have one-stop shop, and this is where you're going to get your grant, because this means that once that grant is over, you have to compete for another one, and it's best to be able to cover the dry period in one with funds from another. And regarding specifically Horizon Europe, we have run into a bit of a bureaucratic problem. So FAPESP joins Horizon Europe through CONFAP. CONFAP does, the Horizon doesn't sign directly with FAPESP. It used to, but it doesn't anymore. And CONFAP and FAPESP's bureaucracies are not always aligned. They seem to think that we can be very fast with some things. Like, okay, here's the MOU signed, and next week you're going to launch a call. This is impossible for us. We need to have anything approved by our board whenever there is a memorandum. So we are working with them to align our processes better. So I think that next year we will not miss any of these calls anymore. But this year I think we missed a couple of them because of that. Because we just heard of them. Okay, it's launched. Now join. We can't do that. I think that pretty much covers it.
If you allow me to give a suggestion, I was here in the morning seeing the talks, And I think they fit quite well in the structure of biota you were showing. In terms of some talks dealing with observation, either ground-based or with remote sensing, others with modeling. Well, in fact, I don't see modeling as a priority in the structure of biota, but maybe it's there somewhere. And other talks like mine and Pedro's on experiments. I don't see it explicitly there, and so I'm a bit suspicious to say that, but I take the suggestion given by Tomás. So no matter how this continues, if with a call or a movement for simply integrating the project, I think it could be organized in that way in terms of observation, modeling, experiments, and maybe adding a fourth component there, which is already in the biota, which is the interaction with public policies or even private policies.
No, just to say that the Biota 2030 was much more organized on thematic issues, on challenges, and not on the methods. But for each thematic issues, we will have different methods to achieve the answers that we do want. So from observation to experimentation, and I really like this. And just to say also that I agree with Christophe to have this portfolio as bank investments. You need to have a diversity of options. And Belmont Forum, I think also it's a good option for multi-country collaboration, and we should move on this direction, but also on bilateral collaboration. Yeah.
Thanks. So Jean-Paul, I was just going to talk about Belmont Farms. I wanted to say, just so that I'm not just provoking for solutions, but also offering possible solutions. Exactly with that thought in mind, we discussed the Amazon initiative with the Global Research Council. Not everybody knows the Global Research Council. That's like a club for funding agencies of around the world where we meet most of our counterparts. And we presented the initiative to the last Global Research Council meeting in early June. And we came up then with the idea of proposing the initiative and its repercussions on other tropical forest systems as a CRA, a collaborative research action, to the Belmont Forum. So this is an actual mechanism. The Belmont Forum is a very well-established mechanism for multilateral funding of global scale research problems dealing with the global change. And this is a possible mechanism where we can use to integrate our research efforts. And when I say the Amazon, of course, I mean as a key problem for biodiversity, but we shouldn't stop there. Nor does FAPESP specifically need to stop there, so much so that we're finding other research that doesn't involve the Amazon biome.
Is there any other questions, comments? If not, I think we are just on time, so we should leave 4 p.m. here. And so just in name of FAPESP, I would like to thank IPT for providing a room for us to meet and welcoming us here. Also, I would like to thank the Consulat Général de France and the German consulate that also co-organized this meeting and providing this opportunity for discussions. And I think that's it. And thank you to the audience also for being here up to the end, and hope to continue this discussion in other moments, and maybe in 2 hours, I think so. Thank you very much for all. Thanks, FAPESP.